Right, so a live stream, finally. We had stream on this channel previously, but quite a while that I've done a stream here on YouTube. And yeah, I'm gonna plan to do this now more often. As you can see the title, we are gonna develop a game engine. I'm just gonna again, like every stream, especially since I have today completely cleaned up my whole desk, all the monitor, all the USBs devices, audio devices, everything. I've put everything down off the table, cleaned the table, and moved everything to different setups. So I have no idea if everything works. I mean, I see my audio is kind of working. I see my face, but I'm gonna need a bit of time to validate that everything works. I'm just gonna start out here talking a bit trash, and now that I've talked a bit trash for a while, I do want to quickly check that I'm seeing something. All right, so there we have the stream. So can I now see what's going on? Okay. I also bumped up the resolution a bit of that stream. Can I see that stream? Can I see it here? Yeah, I have a good connection. That's important since I am now using like double of the resolution. I previously streamed on HD and this should now be 2K, 24 FPS. And I have no idea if everything works. Let me quickly verify that. I have the stream. So can I now? I can hear myself. That's already good. So one thing that I want to test is a simple chat test. Just gonna chat a little hello world in, and it should also pop up on the stream. I don't know if I chat myself, is it also gonna pop up? I don't see it here in, can I switch this to live chat? Okay, so it seems like my pop-out chat didn't work. Let's see. I do want to get all the, I mean, yeah, this is gonna be probably quite okay. So now we are having some issues. Should also pop up with quality. Okay, so YouTube is not saying that's good. Bitrate is not good. Okay, that's not something that I want to hear. Can I change something? Why that stream is recording? Like, I don't know if my network can handle like traffic for live stream, but it looks good. I hope it's gonna go. That's saying that's good. Bitrate is not good. Okay. But that seems fine. I mean, even if YouTube is gonna give me a warning, it's still everything is green. It gives me a warning, but it's everything is green. Which I assume that this is okay. All right, so now I hope that my audio works. Now I'm gonna add the music in a few seconds to make sure that everything works correctly and everything is dialed in. So let me start my playlist. This might be a bit odd. I've just pumped in a few new tracks that I don't even know. Okay. This is too loud, probably. I need to dial this a bit in a bit because I am listening something. I always have a bit of I hear things different than you hear them. I have no idea if the desktop audio is too loud or not. I'm just gonna pump it down a bit, and I'm gonna see in a second if this works out for you. If you have issues, you can also try this out in chat. Now I just need to fix my chat window so that I can have a chat window here as well. Let's see what's going on. Okay, so live chat. So now this should be there. Let's move the chat to that window, to that monitor here. Just gonna do a quick check. Hello world, which should now be, yeah, okay, now it's working. Now I have my chat working, that's good. And now I'm gonna pause the music again for a second and see if it works. If you have issues with the music, if it's too loud, you can also write chat message. alert, which should now be, yeah, okay, now it's working. Now I have my chat working, that's good. And now I'm gonna pause the music again for a second and see if it. Okay. So I think I got everything set up correctly, and we can really start with the meat of that stream, basically writing code, right? Or also do a bit of talking. So I'm gonna get the music in as well again so that we can also hear something. All right, so I have created myself a little to-do list on a few topics that I want to talk about, and I also want to do some programming today. So basically, these streams that I'm gonna do, I haven't streamed like for a while. I don't know when the last live stream went live. It's quite a while ago that I started the last live stream, but I want to do it regularly now because basically when I had like back 100 subscribers, my 100 subscriber special was a special announcing that I want to write a game engine, and yeah, hasn't happened since then. Basically, I made this announcement in my 100 subscriber special. I don't know if even like the people who are now watching me did watch me back then, but if you were watching me quite a long time, you probably know that video where I announced the game engine. And yeah, now is the time that we want to start this project of the game engine, which is super nice, and I'm really excited for it. But I needed to find a way to actually be able to do it. So the problem is currently that I don't have time actually. I don't have time to bring you high quality videos like the DirectX 12 videos that were not super high quality. I did made some slides, I made them into languages, I recorded this, had code sections, and it was quite big. Right? There was many things that I have done there, many time invested, and I cannot hold this up because, well, times back then were a bit different. It was like all Corona, and I had enough time for doing these videos because I was at home and I was at university, so I had a few hours a day where I needed to attend my my lessons, and like beside lessons, so if I didn't care about it, I basically just quit it out and worked on my videos or worked on the videos aside. But now, again, like normal times, and I need to go to work, I need to go to university, which is like burning a great amount of time. So de facto, I don't have time to do 2 video series on YouTube as classical videos. So personally, what I have decided is that I'm gonna make streams to do that game engine development stuff, and I am gonna continue on doing videos as I have time, and I try to keep them up there always every like 3 days, make a video. And currently it's working quite fine, but we're gonna see. Maybe at some point I cannot hold it up, but the idea is to bring like the videos every 3 days. Right, so the topic of that live stream today is going to be to make you a bit familiar with the project because of the time issue, I don't have time to do it like in a tutorial style. This is not possible for me. I cannot do a tutorial writing a game engine, but what I do want to do is I want to explain everything what I do and try to work like 60 to 80% on stream or on camera on the engine itself. So probably it's going to be Friday because Friday is the day where I can like have the best time slots allocated, but it's not guaranteed that I do it every Friday, or maybe I also do it twice a week. The streams, these are probably just going to be if I like to stream and like to work on it, I'm just going to start the stream and go on. The streams will also be published to YouTube publicly, as there's no like Patreon where you need to pay to get the old streams as an archive. So they will all be uploaded. If you have no time to attend them or you want to rewatch something later, you don't need to make records of that or clip stuff. You just have the full videos out there later. Okay, so let's now get started talking a bit about the project. So when I announced the game engine, this was quite a while again that I announced that I want to write this. I basically also announced the name with the game engine. It actually went quite far with the name. Just to show it to you, I actually did let me generate a few icons. So basically there's like this project called Brandmark where you can like enter a name and it generates the logos for you. I mean, yeah, you know, you're gonna see the URL where you can get there, but I don't know, that doesn't really matter. Hello, welcome to the stream. Yeah. So basically what I've generated is I have generated like logos for everything and used this website here to make me logos for the game engine project, and it was all fine and I really like the name, but I'm gonna change it, as you can see in the title of the stream. Why am I gonna change the name of the game engine? Basically, the name is already taken. There is like a German guy that uses the name Vengeance. Like, I actually did when I came up with the name Vengeance. I actually you can there's an international website where you can actually enter a brand name, and the website is going to tell you if the brand name is already taken. That's what I've done when I came up with the name of Vengeance. And I saw, okay, Vengeance was already used by some people, but it expired. It was no longer an active product. So I decided, okay, I could use the name Vengeance for my game engine purpose. And I also did a Google search on Vengeance, and everything went fine. Now, like a year later, now when I like seriously now considered starting the real development, I checked the internet again. The brand registration is still not showing anything. Nobody registered the name Vengeance, but there is a website which is actually up quite a long time that is using the name Vengeance for quite a long time. And the thing is, like, brands work like this. You don't need to register a brand to own it as a brand. So normally, at least in Germany, it is like that. If you are actively using a name, so basically you are having business cards, you are having a website where it is like promoted, and you are really like carrying and marketing that name, then you have your brand. It's not a registered brand, so you're gonna have a hard time if somebody else registers that name to really prove that this is like your name and you are using it way longer and the other one steal it from you. So I personally, I'm not a legal guy. I do take a few Google searches, and I really don't want to wrap my head around if a name is legally usable by me or not. So basically what I've done now is I have actually changed the name to my original game engine name. I'm always a big Mirror's Edge fan. In fact, I also have like all the, I don't know if your podcast is gonna be happy with that, or like this fan art stuff from Mirror's Edge. And I was always a big Mirror's Edge fan, which actually brought me into like this game engine programming style, because I said like, well, if they are not often doing a game of Mirror's Edge, I do wanna create my own game. And I do want to write, of course, my own game engine for that. And this was like my initial thoughts on getting into game engine development. And so actually my engine always was named ProEdgeEngine, like Mirror's Edge, ProEdge engine, game engine. So I kind of like took that name because I really liked it. And then later on, because I had like 20 versions of ProEdgeEngine on my disk, starting at like where I initially began C++ development with like just a console and a few routines to write some text on there and to read text, and the name kind of like was done for me, and I was like, yeah. However, now I have this YouTube channel, I have this community I'm going to start full in, and I'm going to go with a new name. Right? This was my idea back then. And since like all of this stuff, and I didn't really get in trouble with just the name, so I actually decided to go away from that name and to go back to my original name, ProEdgeEngine. So does it really matter what the name is? No. Actually, I already had a bit of code started with like the term Vengeance and Visual Assist, just a quick renaming documents Control F for searching and replace, and like I migrated an existing project in like a few minutes down to a new name. So does a name really care? Does a name is a name really that important? Yes, it is for product identity, but not for us ourselves. So really, it's not it is not really like important for you how the engine is called. You heard that little ding. This little ding was basically the Microsoft To Do thing, where I basically checked the task by basically have a list here on the left that shows me what I want to talk about today before we start development. All right, so speaking about the next topic, I announced the game engine back in. Let me actually check this. We can check this. I can tell you exactly when I announced that game engine series. How many sites do I have to go back? Probably a few ones on YouTube. Modern GX, this is like way after that announcement video. This is really a long time ago that I announced the game engine. I think it was somewhere in 2021. Not even that long ago. It's like a bit over a year. So the 19th of April was where I announced the game engine 2021. I had my 100 subscriber special, and I basically had the so I had my 100 subscriber special, and I announced the game engine series, and it never come really to plan. I never did a video on that, but I started earlier, but let me quickly respond to that comment, which kind of like brought me out of context because I read it while talking, which is always not good. But yeah, that's interesting. I actually have put the Trello board on public, but I have actually changed the name, like all that namey stuff, what I've talked about with that Vengeance to um, the name changed from Vengeance to ProEdgeEngine is actually quite recent. I think I did it yesterday, and the board was like created on Vengeance, so I renamed it. Maybe Trello has then changed the name or the visibility to private again, but we're gonna check this in a second. Um, yeah, P. That's actually yeah really interesting. And when I started like this programming stuff, I actually had namespaces called P, but now it's like I'm personally going to refer to it as PDK. Pro-Agentic Development Kit like. I mean, yeah, it's super stoned from UDK and VDK would be even cooler, but PDK is also, I think, the name that I'm trying to force throughout the series there. So, yeah. But P is also a nice thing. I wouldn't really bother if people call it P. I mean, it's kind of funny, right? Okay, but yeah. Let me quickly check this Trello board. I think I already have it open here. This should be public. So actually this workspace should be public. Yeah, the workspace is public, and actually the board should be public as well. How can I change this? Workspace. Yeah, it's a set. Okay, workspace doesn't mean. Okay, I thought that maybe if I put this to workspace, it automatically inherits this from workspace, but it's just public to workspace members. So yes, make my board public. Yoo-hoo, you can see it now. Now it should be good. So good. Going back to the point, why did it take so long? Like I said, this was like 1 year and 5 months ago that I announced that I want to write that game engine. Probably the most guys of you are not even familiar back then because I just had 100 subscribers, and like I don't know if you watched an old subscriber special, probably not, because I don't know even, was it already English, the old subscriber special? I think yes. Yes, it was during the DirectX 12 area, so it was on English. That's good. At least something. But I mean, like, this video is super unpopular. Okay, I had videos that had less views, but it is kind of unpopular. And yeah, why did it take so long? So I started development on, like, back then, no, codename Vengeance. Let's just call it codename Vengeance now for a second. I started multiple times and I had multiple approaches, and some of them I did like them and some of them I absolutely hate them. I navigated myself a few times in the corner with the build system actually. I tried out multiple build systems during that initial development that I tried, and I really didn't get something working that I liked. Like, everything was too static, too hard to do. Like, I used Premake, CMake, just Visual Studio solutions, and I wasn't really happy with anything. I actually at some point also tried to implement my own build system for that project, which I probably would do if I'm a company. If I would be a company, I would make the business decision to actually write a custom build system like Unreal Engine or Epic Games did it, because it makes sense. It makes absolutely sense to do a own build system for a game engine. However, I don't have the resources for that. A build system needs to be solid, needs to work, and I could write one, but I really don't want to do it yet. I do have a kind of custom build system, but a custom build system that basically uses other build systems but chains in together customly. I'm going to show this to you in a second. So I navigated myself sometimes in a few corners. I also started like developing with other platforms in mind. So basically I wanted to start developing it so that it can run on any platform, the engine, which is a really bad idea, especially if you don't have access to these platforms. Like, I actually bought myself an Xbox. I used Xbox, like I think Xbox One S or something. I think One S was it, like the small white one. I think it's the One S. I bought myself a One S from eBay, used, and put it into developer mode so that I can test out code for Xbox. And the thing is, if you are familiar with developing for Xbox on a non-game engine or a non-game industry base, it's called UVP, Windows Universal Platform or something like that. And programming UVP is not nice, really not nice. Like they are limiting yourself really down. You have not all resources available. The Xbox reports lower graphic features than it actually supports. Um, Getting code on the Xbox is a nightmare. Validating all these files that you need on the Xbox is a nightmare. In fact, UWP is not a nice thing. So what I tried to do a long time is actually write a build system. Actually wrote a custom application that converts Visual Studio solutions that were generated by Premake, converts them to UWP solutions, because like Premake doesn't really support UWP. It was a hell a lot of a madness. At the end, the whole project failed because we were not able to like correctly link everything together. I tried to use dynamic linking and custom dynamic linking, similar own implementation of COM, to basically link together the libraries and make it platform independent and modular. And this really fell apart on the Xbox, because like I was in contact over Stack Overflow with a few Microsoft employees that were really also sitting there like, this should work, but it kind of did not. And they did also some research and found out that the compiler and the dynamic link libraries on UWP are really a big madness. So after like a long time that I invested in that, where I basically made a COM-like system that worked on Windows, Linux, and potentially also Mac OS X, but I hadn't a Mac there to test it, and it falls apart because it didn't work for Xbox, and then the system itself was also super static, and it was really hard to add new libraries, or not hard, but really big work to integrate a new feature into that system. Even though the idea was very nice and very flexible, it really didn't hold up at the end, so I completely cleared that approach too. And I've come up with a few rules for me now for the new code name ProEdgeEngine. So the rules that I have come up with me is, first of all, don't over-engineer it. That's really important, because I like to over-engineer stuff. I like to have stuff more complicated than it needs to be. Of course, it's amazing. Like in a company I'm working for, everybody loves me for writing amazing software that they can later on change by modifying scripts, even though this is totally unnecessary for the general workings of the software. But if they have a new form of data that needs to come into the software, then they just change the script and it works. You don't need to always call me. I don't need to always rechange the code, do a new version on top of that, and the full software doesn't need to be always redeployed, and it's nice. But do we really need this? I say yes, because I like to over-engineer stuff, but other people say no. And this is, especially if you're getting to a game engine, really complicated, because if you're already like over-engineer the very simple stuff, like I personally had for myself the rule to not use the standard library or at all in the whole game engine, or use it as less as possible. And don't use new, don't use delete, and things like that, because I heard that these hurt performance, because the standard library is slow. But is it really? No, not these days. We really don't have CPU problems anymore, at least not on PC. Like the software that I wrote for the company, I completely used the standard library. I had not optimized anything, and it runs like completely in C++, runs fast, is instant, and does its stuff. So basically my idea is to don't over-engineer it if it's not required. If I see a feature and think, okay, a more complicated feature would be beneficial, I'm still going to write a complicated feature, because I want to have a flexible and nice game engine. I also want to show you something and show a bit off and tell you what you can do. So for example, like layer stack, which is something you probably already know if you're familiar with that game engine development stuff. Layer stack is basically the lowest level of application structure on the game engine. We're going to talk about this later. And I basically went even further, made a hierarchical layer stack, but to later a bit more on that. So we do a bit of over-engineering if it seems beneficial, but we are not going to do it if it's not required. So I'm going to use standard library features like string, map, unordered map, vector, set, all of these like things. String streams really useful thing. Writing your own string stream is nice, and we might do it in the C++ series. Like all of these custom stuff, implementing standard library features customly. I'm going to like load all of this stuff later on back for the C++ series, so that we can basically get to the meat there and learn a bit more complicated than C++ architecture on rewriting like these basic data types. But for the engine, I'm not going to use them because, or I'm going to use the standard ones. I'm not going to use custom written ones at the beginning, because I want to get forward. I don't want to like spend weeks, months writing just custom classes of everything that's already available, and just add a feature like a string allocator, string pooling and stuff like that, so that strings are maybe faster than if you would just use them with real STD strings, because, well, I can't tell yet. Maybe in the future, if we have issues with string performance, we might want to write own string classes and optimize them that they are faster than the standard library. But initially, I don't want to like write something custom, or at least now I don't want to write something custom if I don't know if it's really beneficial, right? You might spend like a few hours writing a whole custom string class, which then turns out to be slower than the standard library, because you're thinking that your custom allocator, which does some intelligent stuff of string repooling it and moving strings around, defracting basically memory, moving the strings around the memory to keep them together, and writing that feature, and you think this is really intelligent because it's faster than allocating every string separately. And on the other hand, Windows might have a very fast allocator on the lowest level that is faster than the stuff that you have written because you have over-engineered it. So I want to keep it simple at the beginning. This is like my most important rule that I want to follow here. And the next rule, which kind of like chains into that, is that I want to get things forward, right? I don't want to spend time writing stuff that I don't need. I want to have something on the screen fast, and I want to start there early on. I want to start, of course, with a bit of 2D stuff. This is something that I'm gonna do because 2D is very simple. I have like written a quad renderer. This I don't know. Do you know my ship battle game? This is also quite old that I've implemented. Maybe I'm gonna show it to you in a second. I've implemented this like on a weekend. Like I started like Friday evening and I was finished on Monday on Monday noon. So I have like a whole game. I've written this whole game like in 4 days, but if you would count the hours together, like 24 hours in general, where I've like dedicated 24 hours to one game and written this from scratch, like with DirectX 12, X Audio 2, no like game engine or stuff like that with custom rendering and stuff. It's super static, but yeah, so this is why this took so long. It took so long because I over-engineered it. I had a few projects that were nice and worked, but fall apart at some point if it was a build system or anything else. So I think that I have sorted this all out. So basically, the last year in programming, I have not really moved forward in terms of how I write C++ code, in terms of the quality or the features that I know. Well, I'm kind of like still from the knowledge 1 year back, nearly the same. Didn't change much. But what changed in like the last year that I was programming is like all that DevOps stuff, the management stuff, that general attitude in programming, forwards programming, like. How are you doing it? How are you planning your stuff? How are you doing your build system? How do you make a build system that fits, but is also not self-programmed or over-engineered, and all that stuff, so that you are not like holding yourself back. This is what I like developed last year. Hi, welcome to the stream. I really enjoy that many people are here on the stream. Basically, the thing is, I don't know when I last streamed, but I think when I streamed the last time I had like way less viewers, and we already hit at something like that I never had before on streaming in general in my life. But I mean, the channel got quite far, so I'm not new to YouTube. I actually do YouTube since I had my first laptop, but of course the first videos and stuff really cannot watch them, and that's also something that I don't want to talk in this stream. But yeah, this channel is really going well. I really enjoy this and appreciate that. So thank you to all people that are listening and are subscribed to the channel, and if you're not subscribed, it's important. But yeah, that's for that topic. Why did it take so long? And that's also what I learned from that. I already did 2 tasks here. Bing bing, so done. Okay, now would be the section where we're going to actually start and dive into the code. But what I do want to show you is, I'm going to quickly show you the chip battle game that I've created. Yeah, I have it actually here. Like, this is a 2D sprite renderer with custom cursor and stuff, and basically this has been created in 1 week. It's a simple ship battle game, not really something. Oh, I have made a hit there, and yeah, it's really going well here. So this is basically the game that I've written, and this is basically written on the weekend. So we're gonna write something amazing here in the engine as well. So let me quickly take a look at the comments. Yeah, that's probably true. Yeah, that game, the video or the live stream, even though we are currently in like this comment stuff, we are getting into the code very soon, where we're gonna actually do and go into game engine stuff. And yeah, that's really true. I mean, like, there are a few good resources out there, and there are also books out there that try to teach stuff, but it's really hard because like even other people are struggling with that. You probably know about which big YouTuber I'm gonna talk, who does a game engine, who also um, has already like struggled or doing it 100% on video, on stream, or anything like that, because it is such a big topic and it's really hard. I initially had like, I don't know if you remember these like old videos, these advanced rendering videos that I have done, which were supposed to be like the ultimate guide for rendering, but I quickly like realized that they are not as good enough as I want to be have them. So basically what I've done is I've basically said, okay, no, I'm not going to touch the advanced rendering series in the current state of my channel. So what I'm now doing is my C++ series, and I'm going to hope that during the C++ series and maybe during the development of the game engine, which I'm going to do in this live stream format, the channel is going to grow a bit further, and that I maybe be at some point where I can dedicate more time into the channel when I'm like done, and maybe the channel also gives me a bit of can I get a bit of money out there. I'm able to do the monetization stuff now since I have passed the 1,000 subscribers, but I'm still like on organizing all the tax work, which in Germany the like getting all this paperwork done is really a big thing in Germany. It's not that easy to organize this and do the right decisions. So I'm still a bit behind on that, but what I'm gonna hope is that the channel is gonna grow and that I can maybe also dedicate maybe one day in a week to just the channel in the future. And this is when I also want to like continue on this rendering stuff in like a professional format, and not in like this I'm gonna stream and try things out, because if I stream and try something out, it might it's like 1 hour to figure out a bug, can be potentially. And if you just want to learn on it, it's always good if you attend this, but like it's not really like something that you can use on an educational purpose on like these high quality educational videos. So this is something that's also planned for the future and is gonna come, but not yet. Yet you're just gonna have these stream-like videos where I'm gonna develop, and you're gonna see all the issues and failures that I'm gonna have, and bugs there, and all the fixing, which is also very important. I think it's important that you learn how to debug your code, how to analyze your code, also maybe how to look in disassembling your code, or the disassembly view in Visual Studio, which is also why I'm trying to do this in my C++ series. Even though people are gonna be like shocked if they are beginners and see all the debugging stuff and things, but it's important that you learn something like that too. How I'm gonna pronounce my name? Well, it is like Ludwig Fusel, and like normally my name is just Ludwig, but the thing is like during my where I learned my job and do my university stuff, basically the teachers that we had, there were a few ones that were not able to remember names very well, and the one guy, he asked at some point, hey, is there somebody who can solder? So solder electronics together, and I said, yeah, I can solder. Yeah, what's your name? Ludwig Füchsel. And then he basically a few days later asked, where was that guy that can solder again? Is it the Ludwig? Because soldering in German means löten, and Ludwig, löten, Ludwig. So this kind of like a funny name, because this channel never was meant to be like a success. Actually, this was like the first channel which you're currently watching that was not created to have success. Basically, this channel was just created for a few videos for my colleagues, which were also at the same university, to were at the same like university, to basically bring them a few videos, because during like the Corona terms, the COVID terms, we really had some issues with teachers that were not able to teach properly during that times, because they were quite old and also didn't have the knowledge for doing like all that with the computers, had just a bad quality video. So I said, all right, I'm going to do this microcontroller videos that are there way back in my channel, like on German back then. And then actually these videos, I just put them to public, said, yeah, wherever, put them to public, and then people watched them actually, and they said, all right, now I'm going to take it off with this channel. And yeah, that's where we are here. Yeah, yeah, Ludwig Fusel, yeah, exactly. That's like, it's kind of like pronounced. Well, if I would create a channel to make English videos, I would never ever like have the idea to put like this German Ö, this O with the points on top of that. This is like a German character, and like I think nobody else has this character than the Germans, and so it's a bit hard to do it. And also like the URL of YouTube is with that Ö, which is kind of bad, but I mean it's working out. So really you can pronounce it however you like, and yeah, I think it's a funny story on the names, and the other name as well was also because one of the teachers were not able to remember my last name and always said Fusel, and then the name Fusel came, and yeah, that's how you pronounce it. Yeah, it's really an issue because it is quite a complicated topic, and most people that work in like game industry or game engine development, they have a tough job because they are developing software that is used for games, and like every day somebody comes and say, oh, I want to have that new feature, oh, we want to have that feature that runs too slow, we want to run 3000 triangles more through your rendering pipeline, we want to have the same system that we have now in Unreal Engine with these high poly geometries, and the people are just, oh no, so much more work for us to do, and they really don't have time to teach this. And the thing is, I'm trying to learn this stuff now since 2017, I think, which is like 5 years from now on. I'm doing this like since 5 years, but also like just on a like personal self-taught level. So actually, except like the public available Unreal Engine code, which I have not really studied, but I have never like worked in a professional code base for game engine. This might change in the future, who knows, but yeah, I've come quite far, and I think that I know enough C++ to get things done, and if we are doing it slowly, like we're starting with 2D and then adding features and building on top of that, it's actually possible. So that's where I'm going to stop just my talkings, where I'm going to open up Visual Studio, and we're going to try and take a look at, or not try, we're going to do and take a look at the code base. I don't know why Visual Studio does like to go open on other monitors, but that's it. Actually, we are not going to start with Visual Studio, we are starting with Visual Studio Code. That was something. We are probably on the wrong folder. Yeah, we are in the wrong folder. Which renderer? I am going to start with DirectX 12 because I know DirectX 12 well, and I know how to do my coding in DirectX 12. Vulkan would be nice to do as well. However, Vulkan is on the lowest priority. Oh, I think I need to maybe try to get some more light here because the dark mode is really darkening up my face. Let's try this out. Now, if this really helps, because it's just from the side and I don't have any proper lights in this room, which I should change as well. Yeah, this is just on the left. This looks creepy. No, I'm not gonna do this. No, that's the wrong light. So. Yeah, that's the case. In university, there is maybe you can get something like computer graphics, but these computer graphics classes are really just teaching you image processing. Computer graphics, we also have this in university. I'm studying electrical engineering, and we have computer graphics even in electrical engineering, but the computer graphics that they are teaching you is just basically image processing. And it's basically putting dumb filters on images and doing some complex math stuff, but yeah, that's not really real-time rendering or graphics that people are really interested in, so nobody likes to take these courses. And yeah, that's true. DirectX is really well designed. It's like everything works. Sadly, it's just on Windows and on, of course, Xbox. And the thing is, just from a standpoint, from business here, it's also the only platform that you're going to support, or the first platform that you're going to support. The thing is, if you're talking about market share and you take away the whole mobile segment, So just take a look at PC and console, and you're trying to find out the percentages. Like, I don't know the exact numbers, so don't name me on that, but I think somewhere over 90% is using Windows for gaming. Like, nobody's using Mac OS X or Linux for gaming. A few people, of course, use Mac OS X, the Apple guys that are basically just downloading maybe a small game to the Mac from the App Store and play it. So there are a few percent that actually use it. But the main platform for PC gaming is Windows, like over 90%. And if you take a look at the console market, it's like 50-50 between PlayStation and Xbox. I'm not going to take Switch into account because the Switch is basically just a glorified handheld, even though it kind of is a console, and it now can run like the old Assassin's Creed because it is powerful enough for that, but it is really not playing in the same league than the Xbox X or the PlayStation or like an Nvidia current gen, next gen, last gen graphics card. So everything with an RTX in front of it. And so really, if you take a look at the market share, we have like nearly 100% PC. Then you have like, let's say 50-50 PC and console, and 50% of console is using Xbox. So 75% of like your gaming systems are running a Microsoft-based operating system which supports DirectX. So DirectX is kind of like the first choice that people implement. And this is also why many games just support DirectX, because they still, of course, support that renderer from the PlayStation, but this is like something proprietary for Sony, and they don't really see the point in bringing in Vulkan. I mean, yeah, now with the Steam Deck and writing Vulkan code, it's getting a real alternative to actually start developing on Vulkan. But the thing is, yeah, if you're planning to publish on Xbox, you need DirectX. And this is why people start with DirectX. It runs on Windows, it runs on PlayStation, and everything is, yeah, nice. I'm quickly going to try out one thing before we're going to continue on. I don't know, did I crash now anything by pressing this button? I cannot try to open up the control panel of my webcam because my webcam has some lights that I might be able to turn up a bit, but it doesn't like to open this. Good, then I'm not going to do it. Sorry. Or is it because this is locked? No, it's just because OBS is not, or Streamlabs is not willing to do this. Alright, so maybe I should just put this to the light mode. This might help us. Or I might be able to, can I tell my monitor to blast white light to the wall? No idea if I can do it. My monitor does has a... Okay, no, it's not working from there. Quickly try something out. Does that help a bit? Maybe a bit, but not very much. Okay. Actually, tomorrow I am on Oktoberfest. Tomorrow. So let's get started by taking a look at the layout of the project. So, because this is something really important. If you are doing a game engine or any big C++ software project, you need to make sure to have a proper build system. And as you can see, you get already spoiled that I kind of use Premake 5. Yeah, it's not that bad, I think, but it would be better to have a bit more light. So I'm gonna try to maybe get like these overpriced Elgato lights, or I'm just gonna take a few of my LEDs and solder them together, which is costing me nothing. I'm gonna see. So coming back to the topic, so I'm gonna use a version of Premake. Yeah, AI is really like a trend today. I mean, it's an interesting topic, and I do plan to go into AI as well at some point. Like, I have no idea of AI. I do maybe know some very fundamental basics, but I really don't know anything about AI. The thing is, I already wanted to go into AI, and then I took a step back and said, no, I'm not gonna do AI. I mean, AI is also important for gaming if you want to like write something, some enemies that are automatically detecting what you're doing and stuff like that, then yeah, an AI is important, or a bot that you can play against with and stuff like that. But really, the fundamental game engine things are things that I need to get done first before we can really go into such things. But yeah, right. Like today, the trend is, oh, we want to have AI. AI is so cool. AI is so cool, and everybody like does AI. And it's also in electrical engineering, they are bringing a full new direction of our topic in university, electrical engineering. You do like the basic electrical engineering stuff, and then you're gonna specialize in one direction. And they are now adding a full machine learning to electrical engineering because like they think, oh, AI and machine learning, we want to go on this trend. And I think, yeah, if you want to do it, yeah, do it. But we even had like a teacher that, a really good math teacher that actually said, yeah, AI is just a special form of mathematical computations that they are already teaching, and now they just need to teach it a bit more. So even if you are being fooled and go into that machine learning stuff, you're basically just going to get some math thrown around, but not really do something practical. But that's a different topic. So let's take a look at the project setup that we have here. All right, so I'm going to use here a form of pre-make in this project, but it's not the pre-make that you know. First of all, I have a very concept in here. It's called the dev tool. The dev tool is the most important tool on that whole GitHub repository that I'm going to at some point also make public, but currently it's not because I do still have some things that I need to change to the license and stuff to really solidify this. So dev tool, it's a command that you can just use. It's used by giving it the name dev tool and action and arguments. And dev tool itself is just a batch script. So dev tool itself, if we take a look at this, at the Windows script, there's also a shell script, but it's really doing the same thing, is just a script which is calling Python. Why Python? I'm personally not a fan of Python. However, for scripting and writing scripts to advance your project, it's a good idea. So what does Python do? Python calls a Python script called devtool, and this devtool Python script is basically just an entry point. The devtool Python script does nothing more than validating your input. You give it an action and optional arguments, and it extracts them here, passing the arguments into actions and arguments, checking if the action is available, and then it's going to mark the action as executed and run the action. So basically how this devtool works is that it has multiple actions that can be run on that repository. For example, generate the projects, resolve the dependencies, maybe in the future pack everything together, clean up resources, compile editor resources or something like that. So basically actions that you can run on that repository. And basically what the generic devtool things are doing, including this like dtlib, devtool lib, is basically just executing and making sure that scripts have run and may run if they need to run, and execute them, as well as ensuring that environment variables are set. And I don't want to go into too much details because this thing would require a whole video series as well. I did actually plan to maybe also bring this devtool like as a product GitHub repository that you can use as well, but I'm really not sure if I'm done with it. This is going to change multiple times, and the idea of this devtool is just that you can run several actions like generating the project, resolving dependencies, maybe publishing executables, copying data around, and devtool behind the scenes is just responsible for dealing with that stuff in behind. And the idea basically is we have a script directory, and inside of the script directory we can generate a subdirectory which is named after the action that we want to do. In this case, maybe generate project or resolve dependencies. And down in these directories, you also going to put a Python file with the same name that is going to be executed by the devtool. So basically what the devtool just does is, if I would write devtool resolve dependencies, it's basically just calling into that Python script that we have here. The Python script here is just having a few helper functions that do stuff, and basically just a Python main like you would have it on anything else. The idea of the generating resolve dependencies is that we can download and compile external libraries. This is done all completely by the devtool itself, or by that devtool action resolve dependencies. I don't want to go into the details how it does that, or if you are interested in that, you might want to leave a comment or like a little chat message. Then I might do a full tutorial series on the dev tool, on just the dev tool. But basically it's just there for bringing the project in a ready usable state after you have downloaded it from GitHub. The idea is I don't want to deal with submodules. I really hate submodules, even though that if you're using CMake they are not that bad, but if you're using PreMake or anything else they are bad. I don't like submodules. I don't like shipping binaries with my application and copying all the files manually into my repository, because if I need to change something, if a new version comes out, I am just there to change all the files, reset all the projects that I might generated, and it's not nice. I want to have this all like nicely intact and clean done with DevTool in this case. Same with generating the project. Generate project is calling into PreMake, and they want to have a uniform way into PreMake so that you, the user or programmer that is working with the game engine, with the ProEdgeEngine, is not responsible of passing the right arguments to PreMake. So it's really just calling PreMake, right? And in this case, it's also making sure that the dependencies are renewed. Or not renewed, just resolved or renewed on demand. So basically what's happening is we have a file called dependencies.py, and this file dependency.py is responsible for setting up all dependencies, and they work in like a programming style way, even though they are just a few like tasks that needs to be done. So for example, we are using PreMake for building the project. So we have PreMake 5 as a dependency. Basically what I'm going to do, we have that function, what is that? We have the function here called dev setup dependencies. So the function is called setup dependencies, and it gets a context. This context is a Python object that I can call functions on. In this case, I'm basically telling the context that I want to add a new dependency. In this case, I'm going to add a dependency with the name PreMake 5, which is to be targeted in a folder called PreMake 5. I'm just going to give it a home page so that we have a bit of information available. The actions that need to be done to resolve the dependency are passed into that lambda, and Python doesn't support multi-line lambdas. This is why we are doing a tuple. I'm creating a tuple out of the return values of these void functions, basically. And these functions are responsible for downloading PreMake. So basically what I do is I download a zip here by calling like this x, which is a parameter to that lambda. I call the function download zip on that, give it a URL. It then basically downloads the zip and decompresses it. And then later on I can basically tell it to copy the PreMake5.exe out of that zip. Done. Finished. This is really simple. Then I have a bit of a more complicated recipe for that dependency, which in this case is AngelScript. I'm going to use AngelScript for scripting because I really like AngelScript. As you can see, I'm basically also downloading it from the web page here. Then I replace something in the file. By default, AngelScript uses a static runtime of Microsoft. I do want to have the dynamic linked one, so basically just control search and replace. All in that solution file. Can do this with the dev tool here. Has a special feature for that, and then I basically say that it shall invoke MS-Build. So MS-Build is the Microsoft build tool, and I basically just give it the arguments that it needs to do. So all the arguments for building it on debug and release. And after that, I basically have the compiled library ready to use. And to use it, I need to copy it over. In this case, I basically say that inside of that downloaded zip, and after compiling, the include headers are inside of the SDK AngelScript include directory, and they shall be copied to a folder called include. Then I'm going to tell it that it shall copy another directory, in this case the library directory. The library directory is basically the directory where the binaries have been compiled. Then AngelScript ships with a delete me file that is inside this library directory. I copied the full directory, so I make sure to delete the delete me file, of course. Then I basically tell my build system what I need. So in this case, I basically tell my build system that that we have a new include directory. The include directory is called include. We have a new library directory called library, and we have some libraries for release and debug. So AngelScript and AngelScript d.lib to basically tell the build system that these files shall be linked with our executable. what basically the dependency resolver is doing in the background is it is basically recording all these dependencies and resolving them while downloading, compiling this, and this is just done once. So you can see actually resolving two dependencies. It says pre-make already installed and AngelScript already installed. Because they are already there, I can actually tell it to renew the dependency, which is done by calling this with renew, the argument here. To run this, I cannot run this directly from here since it uses Microsoft Build, so I would need the developer command prompt for VS 2022, which is the right one here. Let me quickly copy the path here. Let's go to the directory and let's say DevTool. Make this a bit bigger so that you can read it. If I would basically tell it to resolve dependencies, no, okay. And then I give the action renew. You can now see that it's downloading stuff. It's downloading, unzipping, copying, resolving, and now it's compiling AngelScript, as you can see. So in this case, it should be the debug build. I think if the first build was the debug build, so you can see it's compiling all these files on demand with the dev tool. Now it's compiling it again on release mode or on debug. I don't know which order I have put that into that function there. So yeah, it's done copying data, copying include, lib, removing, delete me, copying the add-on directory, generating dependency pre-make script, deleting temporary data. And after that, DevTool, the dependency tool is basically done. You can see that we have a directory called dependency here. There's a dependency.lua file, which basically reflects all the Lua dependencies that we need for pre-make. So in this case, you can see we have the links for debug and release that were basically defined here. We have include directory set up here, which is basically the path to our dependency directory AngelScript, and we copied the whole include directory, so this is reflected here as well. And if we would take a look at this, yeah, AngelScript.h is in here. Same thing with the library. You can see the library is stored here as well. Links and defines, we don't have any, but library we have it. It's here. The AngelScript libraries are here, including the PDB files. The add-on directory is also there. The add-on directory, I copied this manually because it's basically containing some code that we might use in the future from AngelScript, which we then can copy out of there as well. So just because the temporary downloaded zip is being deleted, I have them here ready as well to be used. Now we can also see that this AngelScript directory has this venture.deb file. It's basically just a JSON file that caches like the links, library directories and include directories, so that I can, if the dev tool, the dependency tool runs again, if it runs again and I don't need to download AngelScript again, but another library potentially, I of course need the information that we had from AngelScript as well, so that they are just stored and I can merge them together later on, which is really working fine. And it was actually quite easy to write this with Python, and for things like that, Python is okay. So that's like the idea of resolving dependencies. This should work without issues like that if you are on a developer command prompt. In the future, I might also add to the dev tool a feature that automatically detects a Visual Studio version that you are using and automatically runs the vcvars all, which is basically a batch file that adds all the path variables and environment variables to run a run a Visual Studio build from there. Okay, I got a few questions. Yeah, we should maybe talk about this. I think this is actually one of the guys that I know. We maybe should talk about this somewhere else, because it's hard to give advice on that really quickly, I think. It's hard. Fuck upright. Yeah, it's hard to give an advice there because it's really hard to predict how this works. Processor architecture. I mean, it's really interesting. If you're really interested in just the architectural stuff, it's You could try something out like talking a bit about the NVIDIA GPU architecture and also maybe explain how you could run AI. Yes, I have a Discord. You can. Um, Let me copy the link very quickly. This is, I think, better to talk about this in later on. Let me quickly get my Discord link in the chat here. Where is it? Discord. There we go. This is my Discord link. So we can talk about this in a bit more a different time when I have more time, and it's also hard because I never know like what the actual requirements are for these topics and what I can bring. But what I kind of like would maybe do if you want to combine this, talk a bit about the NVIDIA GPU architectures and how this enables computation of AI. So kind of like NVIDIA has like the Tensor cores. And if you maybe do a bit of research, you can find out why they are specialized for AI, and you might find an example application where you can actually show, hey, this is why the architecture of the GPU is perfect for doing that AI stuff, for example, something like that. All right, but continuing here, let's talk about my pre-make setup. So we have like this dependency tool that handles like with one single script all the dependencies. And now let's talk a bit about the pre-make itself, because pre-make itself looks very, very naked. It autoloads all dependencies that are required. So basically this autoload script is responsible for getting all the pre-generated stuff in. What this basically does is autoload includes ProEdge pre-make Lua, global.lua, and dependencies.lua. Global.lua is the global state, like the dependencies, dependency name, current module T name, workspace configuration, basic filters for platform windows and stuff like that. This is like all handled by this global file. There's just some static pre-make setup. ProEdge pre-make is basically just a collection of functions that make it easier to use pre-make for ProEdge. So basically what we can do here is we can, for example, create a new module which is going to do the basic pre-make project setup. We also have functions like module lib or module headers, module game, where it's basically gonna bring in all the dependencies for creating like a static link library or creating an executable, a game, or have a header only module, which is basically not compiled, it's just there for headers. And what we also have here is like a function to set up CPP, where you can set up a CPP dialect. By default, I'm using CPP 20 for this project. Latest version, yes. True. Actually, this is like really not working in the actual pre-make version. I would need to try to maybe update my pre-make if they have a new version on that, so that we can get this in properly. Because currently, like CPP 20 is, I think, if it generates a solution or project and need to verify it again, but it's going to latest and not CPP 20, because like when pre-make came out, Visual Studio didn't have the switch for 20. So they basically use latest on that. Fine. Basically, this just makes it easier to use, but we really don't care about how this is implemented. We want to see how this is used. So basically, what our root pre-make file is doing, it's basically telling pre-make, or Lua rather, where it can find modules, where it can find code. For example, it tells that some code is in source PDK engine, some code is in source PDK runtime, some sources in source PDK editor, another code is in source PDK tools, and some source is in source examples. So basically the idea is engine are the engine libraries, so the core libraries that we write, like our renderer, layer stack, scripting, everything is going to be an engine. Like engine are just the libraries, the core system that comes together. The runtime itself is libraries that you need to bootstrap a game outside of the editor. So runtime basically are libraries to create a game that are basically providing the bootstrap for running an engine, creating the engine, loading the levels, or basically creating the engine correct so that it can load levels. You can basically hit a runtime which level to load, integrate this with maybe Steam, other libraries, other platforms maybe, and the runtime basically is where like all gets merged together into an existing game, which is basically then used by the examples, which are the actual game's access. Then on the other hand, we have the editor. The editor are libraries that come together for the editor. Like I'm going to try to follow MVC here, so module view controller. So basically what we're going to have is an engine, we're basically going to have the modules. In runtime, we're going to have controllers that basically bring the models together to a usable form. And views are actually going to be in the game. So like basically this is our model, this is our view, and these are basically controllers. So we're going to have controllers for the editor and the runtime that basically provide different access to the data. And also in the editor things, we're also of course going to have some views that then can be used in the editor executable to bring like the windows up. And then we also have tools here. Tools are basically just some helper executable. So we're going to have a pack tool that's basically responsible for packing files, compressing them, packing them into packages, maybe encrypting them so that we can run them. This is basically the idea here of that. I did want to over-engineer this again. This is why I have some uncommented stuff above here about hardware abstraction layers, but I'm not going to use them because I do want to keep it as simple as possible for the beginning. We might do this in the future, but I don't want to. I started doing hardware abstraction layers a few days ago for tests, or a week ago, I think actually, and it's too complicated. It's not too complicated to do it, but it's just too much work, and it's not worth it yet. Even though I'm gonna hate me if I really want to port this sometimes to a different platform. Then I'm gonna hate me that I have not done hardware abstraction from the beginning on. I'm gonna do some abstraction. Of course, I'm gonna have a renderer that is a 2D renderer that's independent from like the rendering interface and stuff like that. But refactoring that will not be a big deal. But it's always better if you have it in first. But in this case, no, because I don't have the time. So yeah. So basically what this function is doing is it's basically getting a folder where it can find the source, and it's also getting a name. This name is used to group the solution in Visual Studio. Visual Studio, you can like create solution folders where the code is grouped. And basically these are just the names for the groupings or the folders so that we have them nicely separated. On the other hand, we have the path. On the path, Premake is going to try, or Lua is going to try to find code. How is it going to do that? Well, basically it follows the path. For example, here PTK, engine. All right, in engine, it's basically going to try to find all folders. In our case, it's finding the folder AppCore, Autoload, Util, and Windows. So basically what it does is it iterates through each of these folders, and in each folder it tries to find a build.lua. And if it finds this build.lua, it's going to include the build.lua. And how does the build.lua looks like? Well, most of the time just 3 lines. First of all, it defines that we have a new module. In this case, a module is named AppCore, and the target name is PTK-Engine AppCore, so that we have a bit of a better naming scheme there, that we can see it a bit better. So actually the library will be called ptk.engine.appcore.lib. And on the right, we have another path to the source, so that we are just showing that the source is there. I think I could have also constructed this a bit better, but in this case, it don't really matter. I just put in the path there. Right, okay. After that, I'm basically saying what this module actually is. In this case, it's a static library. So basically, let's say PTK module lib, boom, it's a static library. Then it's written in C++, so PTK module CPP. Done. Setup completely done, automatically detects all code that is down there. And if you want to have a new module, you just make a new folder, create your build.lua, and finish. Run that script again, done. No need to go into complicated Premake setup. Everything goes automatically. Nice thing is, we have this Premake 5.lua, and basically each static library is registering itself as a static library. So if every time you have a static library, it's basically going to append its name to a global Lua array. And as soon as we're going to go to the exe files, because they are after the static library files, so the exe files basically consume the array that has been created. So basically reads the array and sees, all right, there are so many static libraries, and then it automatically on the link to all of these static libraries. So it's all automatic. We don't need to manually fiddle anything around. I'm completely relying on the compiler and linker to stripe out everything that we don't need, which they're gonna do, because this is like the whole purpose of these applications. So I'm gonna take this as an advantage here. Okay, so that's everything that I talk about the build system. So the build system is done. I'm gonna take a sip of water. And now we're gonna talk about the actual code, right? This is why you're all here, talking about the code. Right, when you run dev2, or better to say, DevTool generate projects. Generate project, yeah, just project. Then it's gonna generate a Visual Studio solution, ProEdgeEngine, SLN. I think I already tried to open it here. Let's do it from the CMD. Yay! You see that Visual Studio doesn't open. I see it on a different monitor, and I quickly need to wait until it's loaded. There it is. So that we can start on that. Alright, so let's now go into taking a look at the code. We're going to start by taking a look at, we are going to work ourselves from very abstract to concrete. So we're going to start with the main.cpp of a game, of an example game. The engine is not really doing a game here yet, but this is like an application that is running with the engine. We can actually do, I think, this was like the optimal thing that I figured out. We're gonna see. If it's too small, I'm gonna zoom in even further. Alright, so this is the main file, and this is how big every main file of the engine is gonna be. This is always your main file of that engine. PDK autoload class macro. Then you give it a class, in this case minimal app. This is the class that we want to autoload, and this autoloading function is going to do everything. Or actually it's a macro, and this is going to expand to a main function, but get the point. This autoload is everything that you need. So how does autoload work? Autoload is a really simple macro. It's not doing much. Basically what it is doing is autoload itself for a class is going to create the autoload function. And inside of this autoload function, we're going to have this PDK autoload arg iterator type. Sysargs initialized by PDK autoload arg init arg iterator init. And then we're basically going to call a function inside the autoload class from the ProEdge development kit called load. It's a templated class. It gets a the class as a template parameter, and it also gets these arguments, the system arguments. So this looks very abstract, but what's really happening there? So basically the idea is that I want to support native Windows apps. So I don't want to have the console every time, but I also want to support to maybe in the future have a console. So this is why we do it like that. So basically what I have is I have a argument iterator. The argument iterator is an interface. Argument iterator. It is an interface, a templatable interface. And basically what it does, it defines the behavior of an iterator. Iterator, very simple. You can dereference it to get the value. You can compare it to any other iterator, and you can increment it with the increment operator. The iterator itself also provides a function to get an end iterator in itself. So the end iterator will always be going to be well defined. And this is everything that you need to use this iterator. So basically what we have here is an iterator that gives us a tchar, which is the type of a char. I didn't actually limit that. I should have limited this to just char types, but that really doesn't matter yet. So basically what we get here, if we have this argument iterator, is we have an iterator that gives us strings. Every time we dereference it, it gives us a unique string, and if we increment it, we get a new string. And as soon as we increment it at a certain point, it is equal to that end iterator. So basically we have a list of strings that we can get out of this iterator, and that's exactly how arguments work for a C++ application. So if you have normal C application, you have the char pointer, the array of arguments, and an integer that shows you how many arguments you have. On Windows, this is different, and this is also why we have that full iterator madness here. So basically, we're going to have two implementations here. Currently, I just have one, because again, I'm not going to over-engineer something, and not if I don't need it. If I need it, I'm going to write it, but now I don't need it. So what we do have here is an implementation of that. We have the Windows argument iterator, which is of type wchar. So basically, what this Windows argument iterator does is it basically calls the Windows functions to convert the arguments into the argv and argc that is used for C, and then provides them inside the iterator. Implementation really simple. On the construction, we are calling the command line to argvw function, which is basically converting the Windows command line into the argv and argc that you know from Windows. Then I'm basically gonna access the end iterator. The end iterator is just a static iterator that's living statically in the application. And I'm basically just going to set the end position to the argc position. So basically I'm telling at which argc we are at the end. And what I then can basically do is, if I have that end, determine if an iterator that is at a certain position is the end iterator or not. What I do if I destruct that class is local free, because this needs to be local freed, that argv that you get from that function. So I'm doing this here as well. Dereferencing, very simple. We have this argv array, and this is basically just a matter of accessing argv at the current position of the iterator, so a very simple access there. Comparing is also very, very simple. We are basically, what I'm doing here, I'm casting this I argument iterator to a Windows argument iterator. This needs to be done so that we can access this. And I'm basically comparing positions, so very simple. Incrementing, also just a matter of incrementing the current position. So very simple implementation here, or very simple code packed into a complex concept, but required to make a uniform entry point for an application if you want to support Windows and native C applications. Just a purpose to fulfill Microsoft needs. And basically what happens is, in case of Windows, this macro isn't intact yet because I don't decide to have multiple platforms in here, so it's just commented out. And basically what's happening here is it's basically setting a few things. First of all, the autoload function is the Windows function, so ptk autoload win main instead of like anything else. Later on this could be anything else, but in this case it just resolves to that win main, which is basically just a automatically generating win main. So basically just the head of a win main, the brackets and the source is basically just passed as is into the win main. And which source do we give it? Well, basically we call it down here, the autoload function, which resolves to that win main function. Basically that is the body of our win main, or potentially any other main entry point. But then, of course, since these are macros, it's going to change. Now, the first thing is the argument iterator type. In our case, since we are Windows, the iterator type is going to be the ptk autoload Windows argument iterator, because we are Windows, right? So this is basically just replaced down here as the Windows argument iterator. It's called sysargs for system arguments, and it's being constructed by another macro, ptk autoload arginit arg iterator init. And on Windows, on the win main, it's called pcmd line. This is the command line. So basically in here, for that arginit, we're just going to pass the pcmd line to that argument iterator. And by doing this like that, by basically just changing these two macros, we can generate this for any type of iterator that we might have, if it fulfills our interface of the I argument iterator. Down here, I'm basically now just returning ptk autoload class system argument. So this is a function, a templatable function, which takes a class in here or a type name in here. The class is the class that the user has given to that macro, which basically just passed on. And we give it as a parameter the system argument so that we can work with that. What is that really doing? Well, it is going into the, where do we have it? We should have an implementation to that. Is it an autoload.h? Nee, where is it? I think is it iAutoloadable? Yes, it's iAutoloadable. All right, iAutoloadable is the interface for loading applications. So basically, as you can see, everything can be loadable if it implements the iAutoloadable. iAutoloadable has a virtual destructor since it is a so it's an interface, so it needs a virtual destructor to make sure that everything works. And what it basically gives is a function, a virtual function, which returns an integer, because an application returns an integer as a result code. And the function is called autoload and takes as a parameter and ptk autoload I argument iterator of type wchar reference. So as you can see, basically, this is just taking the iterator that I've just explained here to you. So basically, these are our comment line arguments. So basically what this is, it's just a glorified main function. It returns an int, and it gets a reference to an argument iterator to iterate over our templatable arguments. Or not templatable, but our arguments of the application. And it's basically just a main function, a glorified main function inside an interface, so that we can have like any class that can be autoloadable. This can have like an iMainable class as a main function, can have a main function attached. And what I basically have for that is the load function. The load function actually consists out of 3 load functions, because I also support adding arguments to that. This is something that I want to do later on with variadic templates, variated macros, so that you can also add your own arguments to your own autoloadable class. So basically what happens here is you have the type name team. The type name team is only allowed to go in if it is based on the iAutoLoadable interface, and it's also only allowed to go in if it can be constructed with no throw, so it doesn't throw an exception when it's being constructed. So that's important because we are still like at the top level of Windows. We are not in an exception safeguard, so we need to make sure that we are no throw constructible. And the same thing goes down here as well. The only thing that changes down here is that we have one argument or multiple arguments. And basically what I'm just doing is it just depends on how I'm going to create the instance of that class that it has been given here. And basically here you can see we are just creating the instance with no arguments. Here we are passing the one argument. Down here we are passing multiple arguments. We are variably pushing them out, the arguments. And down here the last line is the same. Basically we're just calling the autoload function on the instance and returning the value. Of course giving the sysargs as a reference to that. It's as simple as that. Thank you. Thank you for the good luck wishings. Thank you. So that's how autoloading works. Is there anything else that we autoload? Yes, we autoload the Windows SDK. This is just a header to load Windows. As simple as that. I do have DirectX in here already. Alright, so how does our journey continue on? When we are calling our main, we are basically autoloading a class that can be loaded. Basically a class that has like a main function attached to it. So in this case we are loading our minimal app. Minimal app is basically just here. This is the minimal example. The minimal example is basically just the idea to have a minimal runtime example of the engine so that you have like an empty scene. Minimal should be an empty scene or an empty running example, maybe a few objects that move around and stuff like that. In the future, we're gonna maybe have a sponsor that gives us a sponsor to basically see what we are doing. So minimal app, how does minimal app look? Minimal app is of course inside the exe itself. Minimal app is that class. So what is that class? Well, the class app in the namespace minimal depends on the PDK app core layered app. Okay, again, something new. Layered app. What is the layered app? So the layered app is actually an iLoadable and based on a layer stack. So I already told you like probably an hour ago that I have implemented or used a layer stack that is a bit more advanced. So let's talk about the layer stack. What is the general idea of a layer stack before we're going to get started? So basically the idea of the layer stack is to manage your application. Maybe open up an editor so that we can write something on that so that you can see the point of that. So layer stack. What is a layer stack? So the layer stack is a way you build your application. So how could you build your application in forms of layers? So the idea is basically that each portion of your application is one layer, and layers are kind of like processed in parallel or after each other, or basically what your layer stack does. It basically gives turn to each layer so that it can do its stuff, and it may also provide some functionality that layers can communicate with each other. So how would this work, for example? So if we would have a very simple game, for example, how would a layer stack look like? Well, this game might have input and output. So it might have an interface where it receives raw input, gamepad input, and something like that. So we would have maybe an input layer. Like that, input layer. And then we might have a renderer, or window and renderer. So we would basically have a layer that handles windowing and rendering. This layer might be even composed out of more layers, but that's something we're going to talk about later in my layer stacks principle. So window and renderer. And what could we also have? We could also have an audio layer that outputs audio. We could also have a network layer that communicates over the network and enables multiplayer stuff. And we might also have a gameplay layer that manages our scene and stuff like that. How would these layers interact? Well, the gameplay layer, which is managing the scene, would basically need to tell the audio layer that we have a new audio source, for example. Or the gameplay layer would need to talk to the network layer and say, hey, let's send the new position of that player to the server. Gameplay layer could also go in and say, hey, window, renderer, I want to have a new object that I can render. would set up this render object and then maybe return a pointer to that so that we can use it. On the other hand, the input layer might go in and say, hey, I have an input that the button W has been pressed. And the gameplay layer would see this and say, all right, the button W has been pressed. All right, I am gonna now call the audio layer and play a sound for walking for the player. I'm gonna code the network layer and say the player moves forward. I'm gonna call the window and renderer layer and tell it to render the character to a certain other position. So really, it's just an idea of having separate systems sitting in a management structure, in this case like a stack, just a list, and providing some communication mechanisms so that these layers can talk to each other basically. That's the idea. So really simple. What do we have in our game engine? We have a hierarchical, probably written this wrong, a hierarchical layer stack. How does this hierarchical layer stack works? Well, one example for the window layer. In the hierarchical layer, we're going to have a window factory layer. The window factory layer does nothing more than providing functionality to create a window. Under the window factory layer, we then might have our, let's call this game window. We also might have something like if our engine crashes or there is an issue or anything else, we might have a, what's a good example? For example, if you need to log into any like online client, we might have here this online login window. And inside of the game window, we might have the debug renderer that's rendering on that window debugging elements. Or we might have the 3D renderer that renders 3D elements, which would be probably the other way around. So actually the lowest renderer would be the 3D renderer. Above that you would render debug elements, and on top of that you might render UI or even UI between this. So UI renderer. So the idea of my hierarchical layer is that you can like chain them together. Why is that relevant? Well, because if the debug renderer needs to communicate with the 3D renderer, we do not essentially want to go through the online login window. The online login window really doesn't like to get notifications on debug rendering. Like debug renderer, only, for example, the game window and all the other renderers need to know that, because why should the other layers know that? On the other hand, if there's a really important event going on, for example, the online login window, which would also have a sub-layer like the login controller, for example. If the login controller has a bad issue, for example, the online services has been shut down, the game can no longer be played. The login controller might have an event that basically say, okay, this event is really critical, I'm gonna broadcast this to the whole layer stack, and then it might travel through all of that. The debug renderer is gonna pick this up and print a red message on the screen, like online services shut down. And the hierarchical layer stack is kind of like the idea to bring this all together, to optimize this a bit away, have a bit of structure in there, and provide a nice, easy, and usable way of structuring the application. Now we're gonna, in a second, jump to the implementation after I've read the comment. So let's take a look at this. Thank you. I am gonna try to keep it up as good as possible and as understandable as possible. It's really an amazing and interesting topic, so I'm really glad that you enjoy it and you all guys enjoy it, and yeah, it's really fun to do these videos, so thank you, guys. But now, back to the code. Because I need to get things done. We haven't really done programming and we are already like 1.5 hours in there, but that's okay. I actually did not plan to do coding today if you don't get it, but it's important that you are on track with what I'm doing, because I started the programming of that engine and I was not sure if I do some devlog style videos on that, if I do tutorials. I actually initially did tutorial videos on these, but they were too long and I had no time to record them, right? I've like worked a half day on that and I would have like 12 hours of video material that I would need to cut, so like another week of just video editing just to get the videos done, and I did devlog style and I didn't like it. So I think live streams are the best way to really do it. So let's take a look at this. Now, how do I implement this layer stack? Well, the layer stack is in this layered app, But before we talk about the layered app, let's talk about the layer stack itself. The layer stack is in the module app core, and the layer stack is constructed also out of a few things. We're going to start with the iLayer interface. The iLayer interface is the core interface that defines what a layer shall be possible to do. We are using the, I don't know, is it also called compositum in English? Like compositum software engineering. It's called compositum in German. I have no idea if it's called like that in English. Composite pattern. Okay, so it's that's really bright, I know. My eyes are bleeding as well. Why does Wikipedia has no dark mode? I don't know. Composite pattern is basically the thing that we are applying here. Basically how this works, if we would take a look at a class diagram, we would have a client, component, leaf, and composite. So the idea is the client is the layer stack. It's the root class. And the layer stack, the layer stack client basically consists out of one component. And this one component can be either a leaf or a composite. How does the leaf and composite differentiate from each other? Well, basically the composite is itself also a leaf. However, additionally to being a leaf, it has a list attached, for example, a normal vector or anything that you might imagine. And on that list, you basically store childs. And basically what you then have is you have your root composite, and you don't have, basically in our case, subcomponents. So basically if we have a composite layer, we basically have a layer that has functionality attached to it, but also has child layers. So like if we would take a look at my codes here, this is for example a composite. It's a Windows factory layer. It has the window factory attached to it for creating windows, modifying windows, registering windows, doing window operations. And it also has a list of childs. And for example, in the child list, we would have two entries, which are again composites. For example, the game window. It is a game window. It has a functionality attached to, for example, have a DirectX swap chain attached to it, the DXGI swap chain, have all the presentation stuff, all the settings to be a borderless window, a full screen window, a normal windowed window, automatically detecting screen sizes, responding to resizing of screens. All of that logic is attached to the game window, but it also has childs. It has childs, in this case these three, which are actually leaves, the 3D renderer. It's just a basic layer. Right under the 3D layer you might potentially also have some subsystems, but I would not manage them in a layer stack. The renderer would then manage them on its own. You should not over-engineer stuff like that and put everything in a hierarchical layer. Like the renderer is the point where we stop actually with that pattern, but we kind of have these leaves then that are basically providing stuff, and they basically build all on top of it. So basically at the top we are very, very general. The window factory layer, which is probably going to be called Windows, haha, no pun intended, so multiple windows under there, is basically just responsible for providing the infrastructure of creating windows, interacting with windows, updating these windows and stuff like that, sending window messages and stuff like that. Then after it, the game window is basically providing even more control. The game window itself, it is providing the functionality that we need to have a window where we can draw in. But just the functionality that we can draw in. And then we even go deeper and be more specialized and basically have now content that gets drawn on that window. And by providing the structure, we have this all nicely managed through our application. We don't need to care where the instances live. They all live inside the layers. The layer and the container, they are all classes, nice object-oriented, virtual methods, and everything is nice and ordered together. And as long as we don't have performance issues, that's good. And we don't need to change it. So what is the feature that the layer needs to fulfill? I do have priorities on the layers because I need priorities to order them. Actually, my layers inside a compositum, so if we have multiple layers grouped under a layer, they are ordered by priority. Why do I have the priority ordering in here? Because I have different type of events that can be sent throughout layers, and the higher priority layer is going to get the message first and has the first chance to respond to it. So, for example, first of all, the game window should be able to respond to events. So if we enter something like text or mouse input, the game window is the first one that should do it, or maybe the 3D renderer, the UI renderer. However, it's just used to prioritize them and order them inside of the layer stack. No big deal here, other than just doing additional checks while inserting them into a linked list, which you're going to see later. Then each layer has a name. This is also a virtual function. I want to have them with a name so that we can also visualize this later on and see what the layers are and see properties of the layers and have this all nicely ordered, and we can identify them easier. That's the whole idea. Now a layer needs to be able to communicate with its parent. So each layer has a parent. If we don't have one, it's the root layer. And we need the functionality in our layer stack to basically get the parent, talk to the parent, because if we are having events, we might tell the parent that we have the event, so that it just travels like the half layer stack tree around. So we have to get inside parent in here. We have a new subscriber, Benjamin Barrage. Thank you for subscribing, and yeah, I did not change the default Streamlabs subscriber message, which I might do in the future if I'm not too lazy. Thank you for subscribing. Okay, so getting setting parent, I think it's sensible to have this. So a layer is a parent of or an I layer has an I layer as a parent, or none if it is a root layer. Now then we also have the options to append and remove a layer. Appending and removing a layer is important if you want to append child layers or remove child layers. In this case, we just have them as virtual functions to also fulfill the functionality. You can see that they are not required to implement. These functions are implemented by default. They are not providing any default function. Yeah, all of them are actually implemented by default because you don't need them. You just need them if you are on the composite and deal with it. But in general, they have the functionality here to append and remove sublayers. We also have the option to get a child. Getting a child is done by the path. The path is actually the address of the child. So basically, as I told you, I have this like hierarchical view. If I would take a look at this, this one would, for example, be called Windows. This would be, for example, be called Game. OS for online. USFV, because OS is like predestinated to be an operating system online service. This would maybe called login. This would be called 3D or renderer 3D renderer. Or let's just keep this simple. 3D UI and debug. And the idea is that each layer is identified by its path. So for example, the 3D renderer can be found by Windows Game 3D. And you can basically use the path to get to that layer. And you can then on the layer stack tell, hey, I want to have the layer at Windows Game 3D, and you're going to get the layer. That's the idea, and that's why the get layer works on that path here to retrieve it. But you're going to see how this comes together in a second. Get layer stack is also an important function to get the actual owning layer stack. That is owning that current layer. This is done by the append function. The append function gets a layer stack as well, and with that layer stack it can then store it to basically have access to that layer. Now we can see we have a few events. We have 4 events here. We have on attach, on detach, on update, and on event. On attach is a simple function. It's called when it's attached to a layer stack, which gets the layer stack as a pointer here again. We have the on detach function. It's called when the layer is detached from that layer stack or from a composite. We have on update with a delta time, which is basically fired every time the layers need to be updated. So basically our like game loop, that's called once per loop. Our on event function, which is called when a layer event is introduced, which is a layer event here. We're going to talk about events in the future, in a second, later on, minute, 10 minutes, however, at some point. We're going to talk about the events, but basically this function is there for broadcasting events around layers. Now, on top of that I layer, we are building our basic layer. The basic layer is providing a bit of functionality that's required by default. Everything is going to be a basic layer. It's just an implementation of an I layer and another way down the stack, or a bit higher level than just the abstract interface. So you can see the basic layer is constructed by a name. Actually, this should be a string view. I decided to use string views. We can change this on here. String view, like that, and I want to have this as a string view, like that. Which is probably gonna fail in a sec, but no, it works. Yeah, it works because I explicitly calling it constructed, and it works. Okay. Yeah, as you can see, like the basic layer is constructed by a name and by a priority. We have some predefined values that are basically defining our priorities, so that we have a few priorities on hand to reuse, so that we have a guideline how priorities work. And you can always like use these and maybe say, okay, if I want to be a bit higher than low, I can always like add one to that macro later on if I use it. Or subtract anything. This is why I have spaced them out like 10. So that you can also say, okay, I am below normal, but I'm even lower than that, so I also subtract one again. That's the idea behind that, so that you can use a bit of math on these things. I think Windows does the same thing with thread priorities, but not as granular as this is. Alright, so get parent is also a bit implemented because this is caching stuff. This is actually caching the parent, the layer stack, the priority, and the name as an std string. So these are actually held by the basic layer and managed by the basic layer, and they are basically just functions to around it. So setting the stack, clearing the stack, getting the name, getting priority, setting the parent, getting the parent. This is like all implemented by a basic layer because the basic layer is modern the interface. It's providing also some storage for that. It also provides functions to broadcast events. We have 3 types of events that we can send. Or 3 types of actions that we can do with an event. We can broadcast an event, we can notify an event, and we can request an event. What is the nuance? Broadcast means that it goes to every layer. Broadcast events are not handleable. They are basically just events that get broadcasted to every layer that is like on the address space. So we have the send down boolean. Send down basically means that we are sending the event down the stack, and by default we are sending it down completely the stack. If this is to false, we're just going to go to the parent, and if it's true, we're sending it to the complete stack. We also have a travel order. Normally the priority is descending, so from highest to lowest priority, but you could say just to ascending, which is basically inverting the priority and how the events travel through the stack. And of course the event here itself. We're going to talk about events in a second. So broadcasting means event that goes to every layer, and every layer has the option to take a look at it and respond to that event. Now we also have the notify event. The notify event is basically an event that just is notifying once. So this basically goes until it has notified a layer or a layer has responded to that event. So by basically calling a function handle on that event, and as soon as you call this handle function, it stops traveling through the stack. This is why it's called notify. It's notifying something, and you know the name is not quite nice, and in the future I might want to change this, but probably it's going to stay there forever. Yeah. Then we also have the request event. Request event is the same, the notify, but on request it's going to be guaranteed that the function does only return when it is done sending that event. Later on I'm going to implement a feature, or maybe in the future I'm going to implement multi-threading, and basically what broadcast and notify are going to do, they are going to be pushed on a queue, and later on broadcast from a different thread. The request one is then going to be the only one that's guaranteed to block until the event gets handled, because we are requesting something. For example, later on we're going to request the window layer or the window factory to create a window for us. And this is, for example, a request that we really need to wait until the window has been created, and then basically we need to wait here until we are done there and it's finished. And that's basically the idea of this. Implementation, really simple. They all call it the send layered event, which is basically constructing a layered event out of this iEvent interface. If you're curious, the iEvent interface is an empty interface. It's not doing anything. It's just an interface to provide me control on that. It might do in the future, because in the future we might have a bit of functionality attached to that, but currently it's just an empty event, just to make sure that we are always on the same track and we can always cast this. And also, like, we are constructing this layered event from the event that we need to store it, so the iEvent is actually required there. So if we wouldn't have done this with the iEvent, we would need to have this templated. This would make things way more complicated than it is like that. So basically what we are doing here is we are populating the stack here, or we are populating the event here. We are setting the source layer, the source stack, the travel order, the event type, and the travel inner, which is basically going to say if it's traveling down or not. And then we retrieve our parent, and if the parent is valid, we're going to call the onEvent function on the parent. The onEvent function is going to make sure that the event is traveling correctly. I think, yeah, that's exactly the idea. Oh, what? Ah, no, this travel down is something different. I told you total rubbish. Travel inner or send down is even more fine control. Ha! I have completely forgotten that I have that feature in here. Actually, the window factory layer could introduce an event, or the game window. Actually, no, it's like that. The game window could introduce an event that is only sent to events of the same order. So only to like the online login window, not to its childs or the childs of the online login window. That's the nuance there. I don't know why I've implemented that, but I think I had something in mind when I've done that. But it's in there, so I guess it's valid. Okay. So basically the idea is when you're calling this on the basic layer, it is only going to travel to the parent and down. If you're calling it on the layer stack, then it's going to travel through everything, because the layer stack itself also has the same functions again: broadcast, notify, request, and send layer event. If you're calling these, then it's going to travel through the whole stack, and if you're just calling it on yourself, it's just going to travel. It's going to just start on the parent and travel down. Potentially, if you set it to true. But yeah, that's like the idea here. All right, so let's go a bit further in the code. So the I layer and the basic layer are basically building the basic building blocks of creating a layer. But what comes on the basic layer? So by default, basic layer is the class that you use if you're writing your own layer. Then you are going to say, okay, class my layer is a public basic layer, and then you're going to continue on writing your code there. And when you want to group things together, you need the layer container. The layer container is a basic layer, and it has the functionality to attach to append and remove childs, basically. So how does the layer container work? It has a private struct layer element. Each layer entry basically has a layer pointer which it is managing, and it also has two pointers: the layer entry and the layer entry next and the layer entry previous pointer, to basically store the next and the previous element. So this is basically a doubled linked list. So forward and backward linking of that linked list. We also have an iterator to go over these. I don't want to go into the details on all of these iterator implementing. It's very simple. It's like all inlined here. It's just like normal iterator for a linked list. Why did I not use the vector or something like that? Because I need forward or backward linking, and I want to make sure to use a double linked list. That's just the idea there. Yeah, just the idea how I want to do this. And I also did not use the string view here. I think I hadn't that in mind when I started this. Actually, they are missing string view and they are missing string because I'm using both of them. So yeah. What is it doing? It supports constructing with a name and priority as well, and it also gets a memory allocator. I do have in mind to write custom allocators for that engine, which is why this is something really important that I don't want to get rid of. I do gonna provide functionalities to custom allocators. I'm gonna write it everywhere. It's not more complicated. The allocator itself is really simple. Write memory default allocator.h. It's just an interface again, or actually a class, a virtual class with two virtual functions: memory allocator, memory free. Two functions around everything revolves, and it features a few functions that allow you to use that custom allocator for the operator new with new object, with arguments, multiple arguments, and deleting objects. Basically provides all that logic that new and delete does as well around malloc. Just that you have your custom memory functions. And I do provide a default implementation with malloc and free, which is basically now completely reproducing what new does, but not completely, because new is integrated with Visual Studio and especially the memory profiler, which that code is not, but we didn't need the memory profiler because we have custom allocators and we could add our own profiling if we want. And I don't need to profile my memory because I know what I'm doing. Most of the time at least. So yeah, in this case, that's good. All right, so what is the thing doing? So it's basically just a basic layer and also stores an allocator. What does this allocator do? This allocator is just there to access layers or to store layer elements. So we have this layer entry pointer, my first and my last, and these two are basically the first and the last element in that linked list, and we use these to accelerate inserting And certainly we always start at the first one because we need to priority insert them. So we need to start and wait until we are at the right priority step. But I have the last one for iterating so that I can start if I'm like not descanning from the priority. If I'm outscanning from the priority, I'm going from last to first. And if I am descanning, I'm going from first to last to basically give the layers the correct idea of iterating over them. So what is the functionality of that class? It provides a few constructors. We can actually copy. That's interesting that they implemented copying. We have that copy from, but it's not that difficult to copy. Or is it? It's actually not a good idea. Or yes, it is, because we just manage pointer. We don't manage the lifetime of these objects, so it's okay. We support copying them. We support moving, which is the most important thing. Like move operators is nothing. When we are getting to that in the C++ tutorial, I'm gonna be on that point as well. Move is the most important thing that you need to implement, even before you implement copy. Move is more important than copy. Because especially if you're on game engine and DirectX and stuff like that, you're gonna have objects that are always unique. So a texture is always gonna be unique. You're not gonna have a copy of texture. You might have handles to the texture open, but the texture or the renderer itself, the device, it's always gonna be unique. Always. If you are on DirectX 12, you can use DirectX 12 memory management to also have copies of your class. However, if you then have your own acceleration structures around the classes to make it faster, this falls apart. So the idea is really that you write a class and handles. Handles that depend on the class. That they are valid only as they are open, and the class is going to have handles that the user can access. So you can have an implementation and the inner handle, and then it's important that the inner object supports move and the handles support copy, but that's a bit more advanced. To the comment that just came on, do you mean Unreal Engine delegates or general delegates? Yeah. So yeah, that's basically the idea how this works. Also like destructing with clear, having a bit of operator stuff in here to handle copying, moving stuff. So yeah. But what are the interesting features of the class? The interesting features actually append, remove, get child, and the event stuffs. Event escade, descade, descanning, escanning, descanning. I don't know why they are actually public. They should be even more private. But no, maybe I've used them publicly. Nah, they should definitely be private. Kind of tell me what you want, but these are private. 100% private. So, that event, static void on event layer, this should also be private. I don't know why I made this all public. I'm gonna see if our code falls apart when I do it. These are basically just functions that help the functionality. So we have an on event for scanning and descanning, basically on in which case the priority is traveling, if it's traveling from high to low or low to high, and we then also call the static on event layer to call the actual event of the layer so that I don't need to duplicate the code for scanning and descanning. That's basically the idea. Okay, so let's start into taking a look at the implementation, because that's where it's really getting interesting. Append is appending to a linked list, to double linked list. Don't expect me explaining this all down. This is just double linked list madness. It's hard enough to understand the code itself, but it's doing some weird optimization with pointer to pointers, especially when inserting. But I don't know if it's faster, but it's at least more readable and less code to write. And that's where I'm concerned here. So this is basically doing everything, inserting, removing. On update is basically just going through all layers, and plus on update, this is the nice thing if you're implementing your begin and end functions and iterators, that you can use these nice for loops, which I really feared for a few years. I'm not just gonna use them recently because they are not that bad. But I kind of feared them. I mean, they are quite nice, but you know, no. Okay, so on event, checking, as I told you, if it's descanning, calling on event descant. If else it's scanning, calling on event scant. So music off again. So scanning, descanning, basically just iterating through in the other direction. This is where we are using for loops, classical for loops. We basically next and previous, last and first, they're basically starting a different position and going the other way around and then calling the on event layer. On event layer is basically checking if the layer is not the source layer, because the source layer is not really expecting to receive its own event, right? So we are checking that. Then basically we are dynamically casting this to a layer container, and if it's not a container, all right, I know what's happening here. I was a bit confused, yes. If it's not a container, we can call the event on directly. If it is a container, we need to check if we are traveling the inner events as well. If you're traveling the inner events as well, then we are also going to the container, calling the on event function here. So that's the idea here. Clear function, just iterating. Again, very simple. And actually, last should also be a null pointer there. This is something that I forgot to add. Good. GetChild. GetChild is interesting. So what does GetChild do? GetChild needs to do stuff. The normal GetChild basically needs to determine between two conditions. There are two conditions that can be. If the name still contains a slash, we are not at the right container. So if the pchar is found, that slash, we need to find the next container. How are we doing this? Well, basically what I'm doing is I am slashing off the name. How can I slash off the name? Basically I'm copying until I find the char. Basically string copying from the to the name copy from the path. And what I basically do then is then put in a null terminator at the right position. So basically I'm copying the full path to that name copy. It's a bit obscured here. I'm doing a full copy of that name until the buffer is full by the save string copy asserted. And then if I basically can cut off the path, if the pchar minus the path, or basically the distance or the length until the delimiter is less than 128, so it's inside of the range, then I can basically set it to this position at 0, or actually it would be better for me to do this like that to be a bit more explicit that this is the null terminator. And what I'm then ending up with is I'm ending up with everything before that slash in the name copy and everything after that slash at pchar plus 1. And this is what I feed into the getChild indirect. getChild indirect function is calling the getChild direct function with just the name. getChild direct is basically searching the current layer for a layer with the same name that given to the function. So it's iterating through all layers. It's comparing the name of the layer to that path that was given here, so the actual name of the layer. And if this is equal to 0, which means that they are the same, then we have found the layer and we can return it. getChild direct also can work here. If we don't have a slash, we are at the right container and we can directly return the layer that is our child. But if we are not at the right container, we are basically calling this indirect function. And what I basically do with this indirect, I'm taking the name of the next container and I'm searching for that in my container. And if I find that name there, then I'm basically asking that layer, which is then a container, to retrieve the child of it as well for the path, which is like everything after that slash. If this doesn't work, I'm returning null pointer. So yeah, that's kind of like the idea of that function. You mean the delegates from Unreal? Okay. I don't know. I think delegates are really the same than events, and in somewhere I have used one already. I had a video where we were using some kind of delegates in Unreal already. I don't know which video this is, but I like never did a completely explanational video. These are delegates. I don't know where this was, but we used the delegate at one point to use them. But actually, if you can get around Unreal Engine, do it. Unreal Engine in C++ is really a pain. It doesn't really work well. I hate it. That's what I must say to that topic, even though people tend to like these videos. But I hate Unreal Engine in general. I mean, it's a good engine, but I hate it. I hate the way you use it. I hate the way you write blueprints. I hate the way you write C++ for Unreal Engine. I kind of thought that maybe C++ is going to save my opinion on Unreal Engine, but I mean, the engine is good. It has amazing features, but I don't like the way how you interact with it, how you write code for it, how you use it. Like the Neo editor is actually quite fine, but everything else is, I don't like it. But I might do videos in the future. But I have a forum. Actually, if you take a look at my Unreal Engine videos, I have a Microsoft Forms where I can actually make this request, so that I also have it on my list in my inbox. So it'd be good if you're interested in that. Okay, so let's continue on the layer stack. So the layered container is basically the composite, and the basic layer is the leaf. So what is the layer stack? The layer stack is a helper class that basically has a root, a composite as a root, and can then hold layers. So by default, you can see the layer stack has a layer container, nothing more. Root layer container. And basically this is then also called root, and what it basically supports is add layer, remove layer, get layer, to basically add and remove layers to the layer stack by providing the pointer and the path where you want to append it. For removing, you need to specify the path. For appending, you can use it. If you don't provide it, it's going to be appended to the root. And get layer basically uses a path to return you any I layer. You can also use this in a templated way, which is dynamically casting this to your T pointer that you have given it, or the type that you have entered there as well, so that it tries to cast this, and if it finds a layer but it's of the wrong type, it just returns you a null pointer. Just a bit of a helper so that you can use it easily. Update is also very simple. It goes to the root container and updates itself, just passes through. Same with handle event, and that's also just going to pass that through that event. Also these like broadcast, notify, request, send event layer and stuff, it's all going to go through the handle event. We have another function that is called enum layers. Enum layers is there for enumerating layers. Enum layer basically works by providing a callback function and some user data. How does that callback function look like? It is a void function. It's returning nothing. In this case, it's like using declaration. This is why we don't have a name here by the pointer, so it's returning nothing, but it takes as a parameter a void pointer, an I layer, and a depth. So basically some data that you can give the function, and a pointer to an I layer, so the layer that it is currently enumerating, and a integer depth. The depth is basically giving it indication on which level of depth it is. This callback can also be templated. So what you can basically do is you can give it any pointer you like, or actually any type of user data that you want to have. It's just caped here by this is pointer. So any pointer that you want to give it, it is possible to handle these. So every pointer you give it, it's working with that, if that function matches. So if the function and the user data you are later on going to give to the function that I'm going to show you in a second, if they are matching, so the function takes a pointer to the type that you have given, and you're also supplying a pointer of the type, it can automatically detect this. No need to stupidly cast things around, which I always hate with callback functions in C++. The standard, or every library that I know, this is how you do it. This is how you can do like any type of user data. But most of the time they don't do it. Most of the time you need to use your std bind and std madness and std function and stuff like that that I really hate. You just need the user data basically. Okay, std bind is nice if you're calling member functions, but I don't like what bind does. How bind works and the syntax of that std madness. And std placeholder _1, ha ha ha. Amazing. Overcomplicating stuff. This is how I like my callbacks. To make them object orientated. And without some trash interfaces, actually. Of course, interface would work as well, but yeah. I don't know what I want to have OP madness with too many interfaces as well. So enum layers, the function is actually very simple. It takes a callback and user data. And the enum layers templated one takes this templated callback and the templated user data, and just does the casting for you, really. But that's how you can do it simple and easy, without overhead actually. This has no overhead, right? This is like, I could make the compiler can deduce it. It's generating that code, it's going to resolve just to a call to enum layers, and all of that madness here is also removed. It's nothing that costs you at runtime. I think STD bind costs you on runtime because it needs to dynamically bind. It needs to dynamically also generate functions so that the static pointer can be bound to an object. So that's a bit nicer. Of course, it's using this inner layers internal. So how does the class works? It's very simple. Add layer basically checks if the path is just the empty string. If it is the empty string, it basically just parent layer is the root container. It's getting I'm an idiot. Never mind. If it is not the null terminated string, so if it's not an empty string, the parent layer cannot be the root layer. So basically what works if by default we are setting the parent layer to the root layer, and if the user specified any path, we are trying to follow that path to basically get a child layer that is responsible for the path, and then we're going to check if it is valid. If it's not valid, we have exceptions here. PDK exception. Never talked about these, but exception, this is basically very simple. We have that exception.h, which is a base exception. A base exception is just our wrapper around exceptions. Basically, it's just containing the message as an STD string and implements all that STD exception madness. And also what it does is it provides a virtual method to retrieve that exception message on construction. I think it's called on construction, is it? Yeah, it's called on construction. It's then basically doing a bit of string streaming, writing a bit of messages, hey, exception occurred, and then the exception message. In the future, there might be also additional information that we want to put in there, like date, time, and stuff like that, because exceptions might be locked as well. We might lock exceptions in the future and write them to a log, so we want to add this all like to the base exception. And what we then basically have is the VDK exception, or exception in general, which is basically also providing a macro to easily construct them with file, line, and function, which is then provides additional information here. And what I basically then do here is implementing this get exception message, and I also provide this get OS last error message. This get OS last error message is basically just my way of also getting Windows error codes in there, basically just to give you operating system messages. And then here basically function formatting of the actual exception. And how this exception is handled is completely not implemented yet, but I have exceptions and it's nice. I don't want to use exceptions too much. I have one rule. Exceptions are bad. Exceptions are a condition where the whole engine crashes. That's the idea. Exceptions shall never occur in normal operation of the engine. And know that especially talking about Java, talking about C#, not C#, not that much, but Java. I think Python as well, but in Python it's more usable. In Python you can actually get around these exceptions if you call the functions right. On C#, I think as well, if you call the functions right, you can get around these. But on Java, exceptions like so much feels as a programming style to use exceptions. So yeah, that's really the thing that I don't like exceptions, because it has to do custom stuff, and I know. I personally don't like to always construct exceptions, throw them, and jump around my call stacks just for exceptions. So exceptions are like the worst thing that can happen. In this case, a padding layer is not meant to fail. So if the layer is not found, then we have a serious bug. So that's not the case. Yeah, that's right. We could write this like that. I don't need to really check for the path in general, because the default argument is an empty string, so the pointer is always valid. It's never going to get invalid, because either you provide something or you don't provide something. So really checking for the null pointer is not really necessary there. But that one is actually sufficient. But actually, like, this is going to be resolved by the compiler to that. And I like to always, when I deal with strings and null terminated strings, I always like to explicitly say, hey, I mean the null terminator. This is just the way I like it, because this actually tells you this is a string, and I'm checking for the null terminator. And this is why I like to have it like that. It's totally valid to do this differently as well. But that's like the idea that I have behind that, writing it like I did. Alright, so after that I basically just append, and if append fails, then something serious happens as well, so exception is thrown. Yeah, you are true. Like Unreal Engine is always getting weird bugs, and it really, I don't know how you can use it in a productive environment. Like, I have no idea. I don't know if I did something wrong, but like everybody, I always get like the comments of people having issues with like this code reloading stuff, which is true. If you're changing something too big for Unreal Engine, your whole like actors that were built on your component blow up, and I don't know how you can use this in a productive environment. I don't know. I personally am not fine with building a game currently in C++ with Unreal Engine. I would never do this because it's too unstable. It gives too weird bugs. Like the whole management. Like I did this whole video series about the time power in Unreal Engine with like that Life is Strange stuff, and I really had fun doing it until I got to the point where I wanted to implement my linked list with objects that can be customized by blueprints. So basically, what I wanted to do is I wanted to write a base class in C++ as an interface, or like as a base class that I store as a pointer in a linked list, and you could basically feed in anything that has been built on top of blueprints. But this requires me to use that idiot garbage collecting of C++ objects with like interconnects with this blueprint garbage collection, and you cannot control this from C++. You cannot say, hey, create me a new object of that type. No, it doesn't work. You can also not say delete that object now. Unreal Engine does this on its own, but it really does not if you are combining it with C and C++. And so that whole series blew up, and I was not able to continue that because Unreal Engine has some weird mechanics about objects that are garbage collected, objects that are not garbage collected, new objects, non-new objects, and all that madness that tries to automatically do your work, but it really falls apart when you are trying to do advanced stuff like doing linked lists and having doubled linked lists that you can walk backwards and forwards, append elements, remove elements, and have it done. So I thought that I have a good idea, and I did many videos towards that idea, and at some point the whole system broke because Unreal Engine has some weird view of objects. But yeah, that's why I currently don't do videos on Unreal Engine. But yeah, that's the full idea, to being explicit here to help to see the code and see this of the null terminating here. Yeah, true. Right, same thing works here with removing layers. I don't know what I'm doing, but I'm basically getting the child here. Why do I need a layer name? Yeah, I need a layer name to remove it from the parent. Yeah, that's true. Removing objects from the stack is also very straightforward. I get the layer itself. I don't know why I get the layer name like this, because this is not required. I basically, in this case, need to check if that layer exists, or if not. Okay, now we're gonna do it. The layer shall exist. So if not, layer. Or actually, no, if the layer doesn't exist, it is already removed, so this is not an exception that we throw. So actually what we do is that, and what we basically want to check here is layer get parent. So if the layer has a parent, or if the parent is not equal to my, actually, we can do this even simpler. What did I do here? Like, this was totally dumb what I've done here. Sometimes you need to take a look at your code twice. So parent layer equals layer get parent. And if the parent could be found, which should always be, a layer always has a parent. If we don't have a parent, we're removing the root, so this would be a exception condition. So if not parent layer, basically do that. We can basically say layer requested to remove has no parent. And if we have the parent layer, we just call remove on the parent. This is exactly what we want to do here. And this is how simple the function could have been. without doing string madness, because each layer keeps track of its parent, right? So we can also tell a parent to remove it. Makes this function a bit easier and easier to understand. All right, so simplified one function is good. This is when you're looking at your code and have the what the fuck moment, what have you done there? Why is it so complicated? And then you see that it works easier. All right, so that's how it works. Okay, so enuming layers, simple as that. We are basically calling the internal enuming function with our root container, because it's like the root we want to start enumerating, and it currently has a depth of 0, gets the callback and the user data. And what this basically does is it takes this container as a root layer, or as a starting layer, the container to enumerate from. So basically what I'm doing here is I'm iterating over all childs of that layer. For each child I'm calling the callback with the user data, the layer, and the current depth. And if the for loop encounters a layer that is a layer container, so I'm dynamically casting this to a layer container. If it is a layer container, we have a subcontainer, and we can recursively call the enum layers internal again with the new subcontainer, the depth +1, because so now we are one level deeper, callback and user data. Isn't it easier to char parent layer name? Use string copy as for size safety. What do you mean? Why did I have that string copy? Where do you mean? In the thing that I just deleted, or in the other? Where did I have the parent layer name? I think it was in the thing that I just deleted. Was it right? No, that's the wrong layer stack. Yeah, I created an array. So you would use, yeah, okay, yeah, exactly. So yeah, we're basically, what's the difference between these two functions? You mean, yeah, so also a zero initialize. Yeah, that's not really required here. The thing is, this is already the safe string version copy. The thing is, it is string copying, and if it's string copying, it doesn't really care about it. It's always adding the null terminator there. So basically what string copy is doing, it's a safe copy is doing. In this case, it's automatically detecting that this is the 256 size array, and it's also copying from the path to that array, including the null terminator. It's already doing that. It's already safely copying the null terminator. It doesn't care what it currently is inside the parent layer name. So initializing is not really required, because we are overwriting it anyways. And the other stuff that we had down here was not even to assert the null terminator. Basically what this was doing is basically setting the null terminator where the slash was. So it was basically copying 256 characters at a maximum, or actually 255 if you include the if you exclude the null terminator. And what it then does, it's basically then overwriting that last slash that we have with a zero terminator. This is just to basically cut off everything after that slash, including the slash. Yes, this live stream is gonna be saved and uploaded to YouTube. Should be. The settings should still be up. I don't know if I need to explicitly tell YouTube to keep it, but I'm gonna make sure that it is kept online. That's the idea, yeah. It's gonna be saved for later as well. Yeah. Good. So get layer, simple. Handle event, simple. Send layer event, simple. I don't know why I have handle event separate as a function actually. Yeah, because you might want to inject your own events. Might be. So that's the idea here. So sending events also works. It works similar than what we had previously. We already saw that code. Now let's actually take a look at the event itself. This is the only thing that we have not taken a look at. Oh, one class still missing. So what does layer event does? Layer event is very simple. It is providing a few enums. It's providing the type, notify, broadcast, request, response, which is basically request response, also sending the event as a request and also getting a response back when it finishes. So the interaction between two layers, while broadcast and notify basically are just single sender, single retriever, or single sender, multiple receiver, and single sender, single retriever, back to receiver to sender, response to sender. So having like this back coupling. So that's the idea here. Yeah, I think what like the other guy, the Cherno, who made a game engine as well on YouTube, what he has done wrong, quotation marks, is not streaming the changes. What I'm trying to do, of course, I'm going to try to work off screen, even though I don't have that much time off screen. So if I do off screen work like that, I'm going to present it completely in the stream. So yeah, of course, the system are going to be expanded. Yeah, it's kind of like a similar idea, but the thing that I personally see or have notified, actually when Cherno announced that he writes a game engine, I was really hyped and say, yeah, amazing game engine series, but really turned out him developing a game engine and having like a smaller puppy version of it for YouTube. And this is probably because if he would have done a live stream on all changes every week or so, from the beginning on, he would have been able to like keep the people on track with the changes, I think. Because of course in a week many changes can happen. But if you're doing like a stream like 2 or 3 hours a week by explaining what changes have gone into it, what stuff has been changed, maybe taking a look at the git diffs, then you can really explain all changes and what have been done. But the thing is like that these series have like kind of like grown out of the YouTube way. Like he tried to make it as a tutorial style, but this is realistically not possible. Like doing a full tutorial on a full game engine is hard. I mean, like I have a full tutorial series on DirectX, just explaining like what DirectX does, how the GPU works, and all that stuff. And if you want to do this for each subsystem of the game engine, you're never going to have a game engine, to be realistic. If you're really explaining everything 100%, 100% in detail, and writing this, of course, also on screen and doing a full presentation, that you're never going to have a game engine at the end, or a very limited game engine. And the thing is that Cherno wanted to get the game engine done to do games with it. And the actual engine, the usable version of Hazel, like the Patreon version that he promotes, it's a nice engine and probably works nice. I don't have any doubts on that, but the thing is, it's like way far away from that YouTube stuff, which I try to not do. I try to keep this in sync with the streams. I try to explain everything that I do. This is also why I'm now going to do this as a stream, because now I'm just talking about that game engine. I'm like 2 hours and 20 minutes in, and I would never be able to cut this video down. I would have like 4 times the work if I would do this as a regular video than as a stream. And also, like, you can ask me questions, we can interact, we can talk about the stuff here, we can talk about other topics, and it's I think more valuable for all of us. So it's more valuable for me because I don't need the time to cut the video, and especially if you have a video that is like 3 hours long, the people are not going to watch it. People are rather watching a stream replay, which is longer, but you know it's a stream, it's supposed to be long. But if they see a video like 3-hour video, they see, oh no, I'm not gonna watch this. Okay, it's a stream review. Yeah, I might open this up and see what's going on. So yeah. Yeah, that's also true. Like, there is not one way. I mean, like probably every game engine that is out in the world does things differently. There is no way to, or no right way to do it. Of course, you can do a tutorial on top of that. Like I've done tutorials to other things as well, like scripting, how I see you should do scripting, which is probably something what I definitely want to expand to AngelScript as well, which I didn't manage to do back then, and yeah. There is actually, like, there's one book that is really good, teaching how game engines work. Let me give 1 second, I can show you. There's like one book that is actually explaining how to write a game engine, but it's not like explaining how to write a game engine. It's basically telling you what systems you need and how they could be implemented, but not teaching you how to use it, but it's a good overview to do it. It is like this fat, big book from Jason Gregory. Probably, if you're interested in the topic, you already saw it. If my camera likes it, Game Engine Architecture. There it is. Can I put it a bit higher? If you can see it. I think there's already a newer edition. I don't know, is that even the actual current edition? I'm not quite sure of it. But this is like the book, and if you are taking a look at this, you'll get some code snippets as well. But if you read it, you know what you need to write for a game engine, but you don't write. You don't need to really write. Kind of write a game engine for it. Yeah, my screen is a bit flickery because this is full AI. I mean, this is like. I don't know if you know this NVIDIA broadcast that is like doing all that camera stuff, which is still in beta for like 1,000 hours. If it would turn like all of these effects off, you would see something like that, right? And really don't want this. We want to have these fancy features going on there. Let me quickly catch up with the comments, because there were quite a few of them then. Okay, is the repository public? Currently not, because I still need to do some setup there. I still need to make sure that the README is set up correctly, that the license is set up correctly, and that everything is good. So currently, no, the repository is not public yet. However, it will become public in the future. Maybe I get it done until next week when I do the next live stream. Maybe do a live stream on the weekend. I try to make it public as fast as possible, but currently not. But in the future, it will be. Yeah, and this is actually quite similar to what like the book is teaching. It's basically telling what parts of the software you need, what software you need, what systems you need to get working, and everything around that, so that you have everything available that you need to write for. So giving you a bit of basics there. Yeah, this is also something that many people are interested in, like doing the actual rendering techniques. Like, if you're interested in rendering techniques, I can recommend, I'm not going to stand up and find the books now, the GPU Pro series. GPU Pro is a series of books. They are quite expensive, but they are basically, they have written 7 books, which are basically giving you some insights on how to write several rendering techniques. I just quickly need to respond to a call here. So, okay. Basically, these are giving you a bit of insights on how to do some rendering techniques, but this is something you need to framework first. You need to have the engine first before you can like bring in the effects and actually teach how the effects work. But this is something that I do plan for the future, and I am gonna bring the future as well when I am like done with all the basics. Then I can bring tutorials of these. And also here, how to implement the API concepts. I do have a series for these for the API basics in terms of DirectX. It's just a DirectX tutorial series. Do I have it like my... Do I have more? Yeah, I have more playlists. My DirectX 12 Advanced Tutorial Series has like 23 videos just explaining like how you use DirectX 12. It's not how to render something. you only get as far as texturing a triangle in that whole 23 videos, but it's like explaining the API and how to do the DirectX API stuff. All right, now I can see the other comment which I misinterpreted for my camera in Vortex. Sorry. Yeah, that's actually like where the full C++ tutorial series of me from myself is leading. The full C++ tutorial series that I'm writing is like heading towards like showing you how to debug, how to optimize the code, how to write like classes that are actually useful. Because like writing classes and writing classes are two different things. Writing simple classes is really simple, but how to actually write classes, when I first started my first game engine that I tried to implement, which had the features that you can actually change the background color and move a triangle around in 2 dimensions. This was like the first DirectX 11 game engine that I have written back then. And it basically wasn't working well. It completely relied on new and delete because my objects were written, or my classes were written badly. And so basically what you need to do is like learn all this, like how to write your operators correctly, how to write the correct constructors, destructors, move, assign, move, copy, and all of these operators around, the functionalities around the class other than the actual like render, present to the screen, like that metadata around the class, that meta properties, that behavior around the class. It's important that you learn that, and this is like where I'm like leading with my DirectX 12 series, C++ series, C++ series, to like teach the basics as well as the advanced stuff in C++, how to tackle these big software projects. Later on also composite, like deprogramming patterns and stuff like that. Yeah, like the documentation is inside of this book. Everything, the scope is the book really. It doesn't tell you how to implement it exactly, but it kind of like gives you everything you need. It gives you a hint into each direction, and then you basically need to find more specialized literature examples on the book as well. So this is like really. This book is really, this was like the first programming book that I have read completely from front to back, and not just bought and read a few things. So like when I got it into Game Engine, this was like my go-to book and I read it from to back. And I was surprised how easy it is to understand this. There are other books like Real-Time Rendering, which is an amazing book, but really, really hard, especially on the math stuff. Same as these GPU Pro things, these are also very hard on the math side. They are really hard to understand. So if you want to do a real proper real-time rendering tutorial series, you would need to like have like 5 to 10 videos just explaining like the basic math. Not just what every book teaches. Like every book starts with vector and matrix math and then it's done. But if you are doing this real-time rendering, this graphic stuff, no. You need to learn how an integral works, how to integrate functions, common integration modes, numerical algorithms, like all of these math stuff that revolves around this. Yeah, currently I'm not planning on really paywalling this this project. I don't know. I do have in mind to maybe add channel memberships, but I would like to just keep these like paid features just as commercial, cosmetic. It's cosmetic, like add-ons that you have, like that rank. A different color, maybe emotes and stuff like that, what YouTube allows you for like these streams and things like that. I don't know if I do wanna, the only thing that I'm gonna do, this is something that I am gonna do, I'm gonna restrict the use of the game engine. This is the only thing that I do. I restrict the use of the game engine. You can use it for educational purpose, you can write your own derivative engine from top of that, but you're always gonna be like behind my license, which is gonna limit you to non-commercial projects. This is the only thing that I am doing here, and everything else I don't know. I mean, I'm always talking about like this commercializations, but the thing is, it's also I think why like Hazel went in behind the paywall, because Cherno really said, okay, he wants the same thing. He want to make it able that everybody can use it for their small projects, but he doesn't want that like it goes out of hand and everybody uses the engine and he doesn't get anything back. This is like why it's behind a paywall. And I think you can really do this with just having a license that doesn't allow commercial use. So just having a license that says, okay, this is a game engine, everybody can use it for learning, and everybody can use it for writing maybe a game. But if you really want to do and get a commercial game with the engine out here, which probably the engine has a long way to go there. So we really need to a long time until we be at the point where we can actually release a game with the engine. But yeah, I mean, this is basically my limitation that I'm going to have there, and maybe I'm going to add something that we can then with memberships or anything else also use it for commercial views, or you can buy custom licenses and stuff like that. But you shouldn't overthink stuff like that. You shouldn't overthink that when you start this, because right, nobody knows where the project leads, and I'm just gonna put the license quite restrictive. And you can always, right, the thing is, if I'm gonna go now full open source and open boost software license where you do not even need to attribute me if you do a game with the engine, we cannot really go back. Of course, you can go back and say, okay, until now everything is like limited, but like the people can just take the old version. What's going to happen is that other people are going to make a fork from the open source version, and then they're going to continue it there, and it goes out of hand. So what I personally like to do is limit it rather small at the beginning, making it very, very restrictive from the license at the beginning, and later on you can always broaden this up. This is not an issue. Making stuff more accessible is easy. Going back is hard. So until I really know what I'm going to do there, this is also why the thing is, there is no license that fits me, because open source licenses are always built for you can use it for free, because that's the idea of open source. And I'm currently writing my own license. I have no idea if this even stands for, if a lawyer comes there, if it can actually take down the license. I think not, because license texts are not that complicated. They're actually quite easy to understand. And by default, everything that a German, at least I'm from Germany, so if I publish something on GitHub without specifying a license, by default you are not allowed to use it. Everything that gets out there, even if it's public, it's still like owned by me. But if you have a license, it's always better. So I don't know what I'm going to do there. This is also one of the reasons why I'm holding the repository back currently, but I do plan to make it public, because I don't want to be a bit of a guy. I also like the management stuff. Like, how could you get access to Journo's repository? I'm actually a Patreon of Journo, and also like Chili Tomato Noodle. These two guys that are doing like this programming stuff that I really like on YouTube. I actually have a Patreon of them, like the basic tiers. And give them money on a per month base. And the thing is, I had access to the Hazy repository when it was at GitHub, because you need to go to the Discord and you need to write, and it's always a bit hard to get access. And then now we are moving to GitLab, and I was just like, screw it now. I'm not going to go to the source code there. I might in the future, but it's like always from the management standpoint, it's always a bit bad, because you manually need to invite people, and it's a madness. I would rather have that all open and visible for everybody. Same with the video. I did consider maybe putting the records of the live stream behind membership, so that you can only view them afterwards over the Patreon link, but it's probably like, I don't know if it even works on YouTube. I think on YouTube you would need to download this and re-upload it so it works, but not quite sure if you can actually restrict the live stream afterwards. But I really don't get my head around this. For now, everything is free and accessible, and I do like to keep this as is. It's also depending on how things go. I cannot really promise everything, but I try to keep it completely free from the videos and the repository. That's my idea currently. And I don't also want, like, I think my YouTube is like meant to share it. And if I share it on the stream and you see the code on the screen, you could in theory completely type it down. And that's something that I don't like, you don't like, so I'm just gonna try to keep everything public. Alright, so what do we have here? Events. It's really not very interesting. It's just a bit of a handle flag and an inner event pointer that has some dynamic casting, getters, setters that check if it's not an event is only handleable if it is not broadcast, and then basically setting the flags here internally. So very simple. Public, travel inner, travel order, event type, booleans. Actually, it's just a struct, which is hidden behind a class, and then C++ a struct is a class. So yeah, I use a class keyword here, and you can later on use the struct keyword to inherit from the iLayer event, from the iLayer, which is a class, and you can use the struct to inherit from the class, and it's C++, so it really doesn't matter. All right, so that's basically the app core. This is how the application comes together. And how does it come together? No, we missed one class. We missed the layered app. The layered app is simple. The layered app is basically an iLoad, iAutoLoadable. The layered app has a so-called stack probe class, which is a layer as well, and the stack probe is only responsible for retrieving application close events. This is a bit of over-engineered again, but it works. So what is the layered app in general? The layered app is autoloadable. The only thing it's responsible for doing is basically having a layer stack attached to it, providing a few virtual functions that you can override, like on app init, on app destroy, on setup layers, which is basically giving the layer stack as a reference so that you can initialize the layers when the application starts. Pre-update, post-update, which is called before the update is executed. For example, on pre-update is responsible for getting the delta time, and post-update is basically just say, hey, every layer has got its update, and now we are before the next frame, basically. The stack probe here is just a simple layer. The stack probe is the lowest priority that it can have. It's responding to events. Actually, it responds to that layer app event. The layer app event currently only supports one type, which is the close app. And basically what you do later is you create a layer app event of the type close app and populate this app return code, and this is then inserted into the layer stack, and it's catched by this stack probe layer, which is basically just implementing the on event function, and that on event function is going to check what it got, and when it received that close, it's going to store its return code and indicate that it received closed. It is friend to the layered app, so the layered app can access it and then basically correctly terminate the application after an update when this event was received by the stack probe. Of course, it owns the stack probe of that. So in code, to make this a bit more easier to understand, so the app itself basically setups the layer. First of all, it adds the stack probe to the layer stack, and then it calls the onSetup layers event, or basically virtual function, so that the minimal app, which is building on top of the layered app, can basically set up all the layers, so let's correctly set it up. Then it's calling the onAppInit function to basically indicate that everything has been set it up and that the client might respond to that and saying, right, I'm gonna do my own application initializations as well before the loop starts. And as long as the stack probe does not receive the close event, we're gonna receive the delta from the pre-update function. We're gonna call the update function on the layer stack, and then we're gonna call the onPostUpdate to handle all the posts. And if the stack probe receives the close, we can call the onAppDestroy event and then return the return code from the stack probe. How does the stack probe set this up itself? On the onEvent, it basically gets data from the event as the layered app event pointer, and in case this pointer exists, so it was the right event, it's going to switch on the type. In this case, we just respond to the close app event. We set the receive close to true and set the return code to the app return code, break out of it, and say that the event was handled. And then this validates down through here. All right, now let's take a look how this is implemented in the minimal app. The minimal app itself just provides the two required function on setup layers and on pre-update, and does nothing else more. So inside of the app, it's very simple. On setup events, I'm just gonna throw out a message box that says that the events were set up. And then I'm basically saying, okay, update has been called, I will terminate the board. So basically what I'm doing is I'm issuing this close app event and pushing that to the stack. So basically I'm creating this app event, setting the type to close app and the return code to 0, and then I'm going to notify the event through the stack. So I'm going to add this event here at the null pointer, which was the null pointer. I think this was, what was that? The source layer, because yeah, okay, we don't have a layer. This is currently just in the app, so we don't have a source layer there. So this is why I just insert the null pointer. As simple as that. I'm not going to talk about Windows yet because I actually need to go. My deadline for today is 19 o'clock. On Germany here, so only 2 minutes left until I need to eat my dinner, and then go to some already defined meeting with friends. So yeah, that's basically how the flow of the application works. In the next video, haha, no, it's a stream. In the next stream, we're gonna talk about the windowing system that I currently implemented, and we're going to continue on that windowing system and maybe also already start with some DirectX stuff, so basically getting the XGI in. So this is now the last chance to write another comment, to ask a question, so that we can respond, and then I'm going to stop the stream for today, which was actually quite long. So that's, I think I need to, yeah, I think it's a good length. A too long stream is also not good, because it should still be viewable afterwards. So yeah, then I'm gonna say thank you for watching today, and thank you for the guten Appetit Wunsch. So thank you, and wish you a nice evening. Have a nice day. Then come back when the next stream comes, and other videos are also prepared to be published. So thank you for watching. See you in the next stream.